Our resource person have joined. Sir, is it audible? Sudhakar sir?
Yes, Dr.
Yes,
Chobe, it is audible to me.
Yes,
Am
sir.
I audible to all of you?
Yes, sir. Yes, sir. You are audible, sir. Thank you, sir, for accepting our invitation. On behalf of the institute, I cordially welcome you. Sir, we are honored to have you with us. So I introduce about our resource person. Dr. Sudhakar Tripathi is presently working as an associate professor and head IT department, RC Ambedkar Nagar. He has more than 16 years of academic experience. He had been assistant professor in STC department in IT Patna. He did his PhD from IIT BHU in 2014 in the area of bioinformatics, AI, machine learning. He has many publications in the journals of Valedictory. He has successfully supervised 2 PhD and currently 4 PhD scholars are enrolled under him. His area of interest are bioinformatics, machine learning, health informatics, and related application areas. Sir, it's an honorable moment for us to have your prestigious comment. We are truly inspired by your deeds. I hereby request Dr. Sudhakar Tripathi sir to enlighten our minds with his expert talk. Welcome, sir. Please.
Okay. Thank you, Dr. Chobe and Triple IT Bhagalpur and directors and other organizers for giving me an opportunity to interact with the audiences. Dr. Chobe, may I know
Yes,
the
sir,
participants
yes, sir. Yes, sir. Gautam Hundar. Yes, sir. You may proceed, sir. Yes, sir.
Okay. डॉक्टर चौबे मैं ये पूछ रहा था कि बीटेक स्टूडेंट्स एमटेक पीएचडी स्कॉलर फैकल्टी मेंबर्स हैं और मिक्स आर देयर
सर मिक्स आर देयर बीटेक भी है एमटेक भी है पीएचडी भी है फैकल्टी मेंबर भी है इंडस्ट्री से भी लोग तो सर बेसिक से स्टार्ट करें अच्छा होगा
ठीक ठीक Am I audible to all of you?
Yes, sir. Audible, sir.
Okay. Language in English, it will be okay, Dilip ji, or should I mix Hindi also?
Actually, many people are from South. BIT Valor, I think 15 students are there.
No problem.
Religious scholars, many are religious scholars. So, yes.
Okay, sure. Okay, audience. Again, I thank you all the organizers and participants, and good afternoon to all of you. Today, the topic that I have chosen and given by the discussion with Dr. Dilip Kumar Chobe is AI, machine learning, data science aspects in healthcare. Presently, we all are talking in computer science and engineering, the allied fields, at policy level, aspects level, almost in all fields, AI, machine learning, and data science are required, are needed for certain regions. The main reason is socio-economic impact on different aspects. So how one should proceed? One of the major fields is healthcare, in which Dr. Dilip Kumar Chobe is doing very well. We have been associated in some works. So today I will discuss how we should proceed in this field so that we can really do something good which is helpful for the society, not just limited to the publishing papers or reporting it somewhere. If at some point of time it could be utilized, that will be better. Either we are BTech students or we are MTech students, or we are research scholars, or we are faculty members, or we are medical practitioners, or we are policy makers, whatsoever we are, there are certain aspects that needs to be taken care while proceeding or developing AI or machining based models or data science aspects to help medical practitioners, patients, society, other related aspects for the betterment of the society in cost effective manner and in timely manner. That's why I have chosen this topic to discuss with you all how we should proceed in this area. Now, what is the impact? Can anybody tell? What is the scope or impact? Why we should go for machine learning tools, healthcare tools? Because the core practitioners are not well versed by machine learning or AI tools. Then why we need these things to be developed and deployed so that it can make an impact on the society and healthcare sector? Anyone of audience? Anyone from the audience? Am I audible? Dr. Chobe, am I audible?
Yes, sir. Yes, sir. You are audible. I think. Yeah. Is there anyone?
No, it's fine. Just I was asking. Okay.
Yes, sir. Yes, sir.
Then the prime aspect is scarcity of resources. Wherever we need some automated tools, some AI-based tools, or any tools, there is always a scarcity of resources. Then in what term is scarcity of resources? If we see in the healthcare sector, sector is not only related with the medical practitioners or doctors that we generally assume to be. There are diagnostic people, there are medical practitioners, there are bioinformatics people who are very much rigorously involved in drug discovery, bioinformatics, gene profiling, protein function prediction, different type of ion channels, different type of signaling, pathway signaling, etc., etc. Many stakeholders are there. Even if we focus on medical practitioners, just a simple aspect, why we go for disease prediction, why we go for disease management and prescription management, drug management, etc. Even we see that there is huge amount of scarcity, especially in developing countries or semi-developed countries like India and other countries, scarcity of resources. The first thing is that. Then secondly, cost effectiveness. See, if a person living in some remote area is going to some medical practitioner, physically interacting with them, giving them fee, giving transportation charges, etc., etc. Even for a simple application, he is going to pay a large amount of time. Even medical practitioners have less time. If a medical practitioner is going to see in person a patient, its profile, it's all the diagnostics, and then manually he is going to diagnose it and give prescriptions, at least 15 to 20 minutes will be taken. In that manner, cost effectiveness is required for the impact, why we need it. By using tools, machine learning or automated models to predict the diseases, to find out the symptoms, to diagnose the diseases for medical practitioners, for prescribing the medicines in widespread manner. The reach of automated tool is widespread. Nowadays, during Corona, the hesitation to use online services have been wiped out because everyone knew the value of online services that could be taken from home, video interaction or voice interaction, or just having some tools giving your problems and getting the solutions. That is widespread reach is there. That's why it is required. The most important thing is that anytime, anywhere solution you can provide by these type of healthcare tools or models that you develop through AI, machine learning, and data science, so that even in at night too, generally you will say in all our households, if we are getting some pain, heart pain, something like that, which may be dangerous, somehow we avoid it because we see that in the night who is going to knock to the doctor, we are going to pick the car. Even if in able families who are having drivers, cars, etc., they also hesitate to go the hospitals in the night time or in adverse time. They avoid generally. The tools that are being developed or the research that are being done for such type of management will be available anytime, anywhere. Rather than going totally blank, if we are having some tools or some methodology so that we can find out a predictive analysis what is going on with us in terms of health. We can always get medicines or prescription in predictive manner. Then effective prior knowledge generation. Why we need that? The term that I have written here, effective prior knowledge generation. What does it mean? Effective prior knowledge generation means if someone is having cardiac disease, he doesn't know whether he's having cardiac disease or not. First time he's having some pain, some exertion at daytime or night time, whatsoever it is, then generally we hesitate to go the medical practitioner, and we see that after 1-2 days, if the problem is going to be wiped out. So when problems come in initial phase, they are not that much severe, and generally we avoid that. And due to avoidance of that, and due to not consulting with the medical practitioner, we don't have prior knowledge. The disease that have just been initiated may be dangerous after 1 month, 2 months, 3 months, or depending upon the time and the disease type. Then effective prior knowledge we can get from that. And better and timely predictions. No doubt we all know that the machines are better in computational and time predictions. Advancement of computational and storage technologies have given us opportunity to do such type of research and making such type of machine learning models for disease predictions, for drug discovery, for different type of aspects. And adaptivity of online services by the society is the major change. If you will see, before 3 years, there were many apps, many tools that have background in terms of AI, machine learning, data science, etc. But we all were hesitant to use those tools or those aspects. Now, during the corona, people realized that going online and getting prescriptions from online services is not that much hasty. That is also effective enough. And society has gradually accepted that whatever services we can get in online mode, they may be quality services, they may help us, and people are now preferring those online services. There are other aspects that needs to be explored to develop technologies for disease prediction, etc. So whatever research, now government is also focusing on that, we all should do. Whatever research, whatever tools, whatever modalities we are going to adopt, directly or indirectly, it should have scope and impact on the society. And I think, in my opinion, and you all will agree, that in healthcare, there is a vast scope of such automated tool, not only for the medical practitioners, just getting prescriptions to prediction of diseases, rather than in diagnostic systems, in healthcare system, in nutrient system, in chronological disease prediction system, hereditary disease prediction systems, instantaneous disease prediction system, infectious disease prediction system. There are certain diseases which are not dependent upon one type of symptoms. There are multiple type of symptoms that need to be associated with those, and based on that, predictions should be done. Now, what type of prediction in healthcare? Now, the major challenge is we just start, we pick some paper and do some predictions. Then what type of predictions we need to do? What type of predictions in healthcare we need to do? The healthcare is not limited to only for disease prediction. Just we are going to develop some model to predict diabetes, to predict arrhythmia, that is cardiac disease, to predict some Parkinson's, to predict some breast cancer, to predict some other chronic diseases, to predict some BP aspects, to predict the timeliness of some collapse, some brain neurological problems, some psychological problems. There are different aspects that we need to predict, but they all are dependent on bioinformatics applications, that is genes, proteins, different type of pathway signalings. They all are associated with certain type of diseases, and if we are able to perform the pathway predictions, the protein predictions, the gene predictions that are associated with different type of organs of our body or of our animal, and the disease related to that, that will be much better to predict the disease and manage in advance with prior knowledge. Then second thing is predictions related to drug discovery. Drug discovery, bioinformatics applications are there, but drug discovery, doing it only in laboratory is too much bulky. Even if we are having some predictive models, so that we can have some prior predictive aspects about what type of drugs should be discovered in particular context, what type of drug dissolution should be there, it all needs to be managed. Then for diagnostic services, nowadays we will see that whatever diagnostics are there, they need to be analyzed. We are going for X-rays, we are going for CT scans, we are going for ECG, we are going for EEGs, we are going for EMGs, we are going for MRIs, and the MRIs machines are doing it well. But the interpretation is still mostly done by, or the diagnostics are mostly done by medical practitioners. It's always fine to be seconded by the medical practitioners. But again, it comes a scarcity of resources. If we have installed some machines somewhere and we can develop some tools which can diagnose those MRIs, those EEGs, those EMGs, and derive attributes or symptomatic attributes so that predictions could be made in terms of diseases, that will be much helpful for us. Nowadays, there is a scarcity of machines because they are very costly. Even if some machines are procured at some hospital, there are not skilled persons who are going to operate that. Even if we are having the skilled person to operate that and to get out diagnosis of that, who is going to finally analyze that report and give the predictions so that a medical practitioner can prescribe the medicine depending upon those findings and disease diagnosis. These all are problems that we need to predict with these machine learning tools. Then for multimodal analysis in diagnostics, what does it mean? Anybody can tell? What do we mean by multimodal analysis in diagnostics? Anyone from the audience? Anyone?
Oh, yes, sir. I think it means that we are using various type of model for the for analysis of the diagnostic purpose.
Yes, yes, model, but basic thing is it's fine. We can use various type of models. But what I want to say in this aspect, multimodal analysis, yes, a different type of model, but depending upon multimodal data, whatever data we are having, say some disease we are having, some symptoms are just spoken by the diagnosed or asked by the queried by the medical practitioner. Okay, you are having headache, you are having exertion, you are having sweat, yes or no. In whatever term we can regard the data, you are having fevers, whether you are getting good sleep or not. This type of symptoms are one type of symptoms. Then we go for, suppose for CT scan or some ultrasound, then that is an imaging data. We need to extract outcomes from those imaging data. Presently, we are having medical practitioners. They are doing our ultrasound and they are just giving different type of images and they are manually analyzing those images and writing down the symptoms. So I want to say that whatever symptoms we can record directly by the querying by the patient, that's fine. But the symptoms that we are getting in the form of signals, or ultrasounds or imaging or MRIs, they needs to be analyzed and diagnosed. So data that we will be having for prediction of different type of diseases, one will be the queried data that we are directly going to query by the patient, which type of symptom they are directly having. Other type of diagnostics are imaging based diagnostics, temperature based diagnostics, BP based diagnostics, MRI based diagnostics, CT based diagnostics. So whatever input images or input signals we are getting from that, we need to analyze that. So can we substitute those analysis that is being done presently manually, because there is also scarcity and non-reachability and costly aspects for analyzing those MRI, CT. Presently what is happening is someone is going for CT scan. He is going to some pathology or some diagnostic center, getting CT scan done by the machine, by some skilled person. Then some pathologist or expert is there, he is analyzing, writing the report, and then it is coming to the original doctor that we are going to consult with. And they are predicting the diseases. The large amount of time is going to be wasted in that. And the cost is also going to increase. So can we develop some model so that whatever symptoms in terms of direct diagnostic symptoms, queried systems, image-based system, they are coming through the machines and they are being diagnosed by such machine learning models which have been built to diagnose certain aspects, and they are going to be integrated in one go. And based on that integrated multimodal data, we are going to do multimodal analysis and get outcomes. We all need to focus on that. Initially, when we started our research in this area, exploring something, we just started with aforesaid symptoms, say in neurological diseases. We started with psychological system. We started with physiological systems. We started with neurocognitive systems. Then we integrated it. Okay, not only psychological symptoms, not only physiological systems, not only neurological system, but integratively they are going to contribute in prediction one type of disease or multiple type of diseases. So that is the major challenge. Presently, we are going to diagnose what type of disease, what type of problems we are presently facing are. Sometimes disease prediction is not about that. Presently, we are having some visible problem. Sometimes we are having problem, or it is a start stage of some type of diseases, but we don't know due to carelessness. If we can access these type of symptoms, these type of different physiological, psychological, phenotype or genotype of symptoms from our body, and we can put it to some machine so that we can have a prior knowledge whether we are vulnerable to some disease or not, or what is the possibility that we may incur if certain type of symptoms are not going to be managed, or certain type of properties of body or certain type of secretions are not managed within the time, some disease may occur in future. So that type of diagnostics are also required. So that's why we need multimodal analysis. It's not about what disease presently we are facing. If presently we are facing, the symptoms are more clear. If someone is having severe pain in abdominal, symptoms are more feasible. But if someone is not having that much pain, even some complexity, some gaseous problem is there, some type of anxiety is there, some type of irritation is there, but we are not having pain, even then we can have a stone problem, even then we can have some appendix problem. But generally what we do, if we are having such type of problems, we are going to ignore it, because we are not having any emergency condition in our own prediction. What we do, we ignore it. By 6 months, ignoring is 6 to 8 months, it is going to escalate, and whatever problem, it immediately comes to our notice, and then it is going to be late for the treatment, proper treatment. So medical care or machine learning aspects is not just only required for if we are facing presently some disease. It is more required to predict for what type of disease we are vulnerable for future scope. I can give my example. I was not having any type of pain, certain type of gaseous problem, certain type of anxiety, sometimes irritation I was facing. Then I consulted some doctor and he said, okay, go for ultrasound. Then I found that I was having a 12 mm stone in my gallbladder. So I asked him for how much time it would have been there. He said maybe from 1 or 2 years ago. So I asked him what maybe the symptoms for that. Bole gaseous problem, pachna nahi kuch, irritation hona, anxiety hona. I have ignored all these things were happening to me from last 1 or 2 years. But I have ignored because generally I have seen or I have heard that whenever someone is having a stone in some place, he will be having pain. But in most of the cases, you may not have pain and your stone is going to grow. So this is not the case of only stone. In cancer problem, in diabetic problem, many diseases are there who start from very early stages. It's very complex to diagnose the early stages diseases. Why? 2 reasons are there. Generally, if we are functioning in normal way, we think that everything is going to be like this, and whatever we have seen from Facebook or we have heard, we go by that. Generally, we avoid to consult with medical practitioners, and if we are not having any complications, generally medical practitioners are also going to avoid that because they are too busy, are not having that micro level of analysis. In my opinion, our machine learning models or AI-based models are needed in the society so that sitting in our home, paying 10 rupees, 20 rupees are nominal charges and fetching our normal symptoms, whatever we are having, can we have a prediction what type of diseases are maybe complications in future we may face. If we are having that, and if vulnerability to some type of complexity or some type of problem is much more, we can go and consult to the doctors. So the research is needed much more in that field to diagnose whether we are having diabetes or not is easy, and in my opinion less valuable, because if we are severely exposed to some disease, it can be easily explored and we will be facing some severe problems. We will be consulting to medical practitioners and getting medicines. But if we are prone to some disease and presently we are having normal conditions, the prime important thing is that if we can develop some models, some machine learning techniques, some machine learning tools, so that we can predict based on our present symptoms whether they may be microbiological systems, there may be imaging systems, there may be signaling symptoms that we are having in our body, or different type of symptoms or features or attributes that we are having. If we can record that, and presently BP machines are there, different type of automated machines are in cost effective manner, or physiological or psychological symptoms we can directly fetch. And if we can have some prediction about, okay, based on your present symptoms, after 6 months or presently or after 12 months you may face this problem, so we can have an preventive step, not only by the tools, then we can go to some medical practitioner for secondment also. So I think the major focus should be of all of us that we should go for these type of. One thing is that we are going to build the machine learning model for chronic diseases like diabetes, anemia, cardiac diseases, cancer diseases, neurological diseases, and so on. Second thing is that we are having certain prediction module for instantaneous infectious disease. You will be saying that if we are having some stomach infection, it is not predictable 2 months ago. Maybe you are eating something today and you are having some stomach infection, or some UTI you are going to have, urine infection, or some type of infection. So we need models for such type of disease also. We may have chronic diseases. We need models for such type of diseases. Maybe we may have some hereditary problems that may inculcate to our body or our system. We need models for that, and we need models more effectively for predicting future complications that may be arise present, depending upon present symptoms or present neuropsychological symptoms or biological system, microbial systems or imaging based systems, or our different vital parameters, etc., BP, hemoglobin, etc., etc. We are having those facilities and we can predict by that. Why it is needed? Because in every context, it hesitant. If we are having some pain in our left side, first thing come that, okay, it may be gaseous. I would have eaten something that is causing gas, and we are facing that pain due to that. Yes, in 90% cases it is so, but in 10% cases it may be the starting, or after 1 and 2 hours it may cause a severe heart attack, or just a mild heart attack that we don't know. And we also know that this arrhythmic or cardiac diseases are such that if we are having mild heart attack within 1 hour, we may have a second heart attack after 2 hours. Mild heart attack, we generally getting some sweat, some exertion, etc., and we ignore it. Generally, we are hesitant, and there are symptoms not only for mild heart attacks instantaneously. They may start from overweighting, exertions, you are getting anxiety by doing some little work, etc., etc. There are neurological or psychological problems, some physiological problems that we may face, and they are prone to certain diseases. That type of model needs to be developed in very efficient way in a healthcare system. Okay. Now, which type of disease prediction and what to predict? This slide I have left it out. Which type of disease we need to predict, and yes, if we finalize diseases, what type of predictions we need to do? Anyone from the audience? Anyone? Am I audible? Am I audible?
Yes, sir. Audible, sir.
Yes.
Yes, sir. Yes, sir. Audible, sir.
Okay. So anyone from the audience, can you tell me what type of diseases we need to predict? If we are given, okay, we should start with this type of disease predictions. From where we should start? What type of disease needs to be predicted in advance? Or if we are given an option, okay, you start building a model to predict some disease. What type of diseases that needs some type of predictions?
Sir,
I think we can search for neurological disorder
Yes.
or heart disease.
Yes.
Yeah.
so
Yeah, we
cardiovascular
can
disease is also the one.
Yes. 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 You all are
we
right.
can go for
Communicable
lungs.
diseases, sir.
Yes, yes. Everything we can do. We can prepare model for prediction of any type of disease. We can categorize those diseases in 4 or 3 categories. There are diseases that are chronic disease, whose symptoms start in very early, whose inception starts very early, but the symptoms are visible to us, are noticeable to us in a later stage. Do you agree with this? There are certain diseases whose prime symptoms start in very early stage, but generally they are not visible to us. Do you agree?
Yes, sir.
Yes. So in my opinion, these type of diseases are much more severe compared to diseases that are based on instantaneous symptoms. Agreed? If we are having some food poisoning type of problem, or due to heat, we are eating some oily food or something, and we are getting some problem, then this type of disease are not that much sensitive. Our models for predicting these type of disease are not going to work much more, because even if we are having certain machine models to predict this type of disease, okay, I'm having vomiting, what you have eaten yesterday, from whether you are feeling pain or not, this type of regarding we are going to do. The machine is going to predict, okay, you will be having food poisoning, you take some ornidazole or something like that, and you are going for that. Certainly, if someone is facing that type of problem, instantaneous severe problem, he will be going to consult the medical practitioner. I think all of us will be agreeing on this. कि अगर किसी को बहुत ही वाइटल सिम्टम्स आ गए, सीवियर प्रॉब्लम आ गई, तो मशीन लर्निंग टूल एक्सप्लोर करेगा या एक्सपर्ट के पास जाएगा? Whatever disease is there, if symptoms are clearly visible and we are facing the critical stage or semi-critical stage, so whether we will be consulting an online tool or machine learning model or a physical practitioner.
Sir, initially we will consult a practitioner only, and after that, if machine learning tool is developed in such a way that it can be more accurate, and after a certain time when people will start believing in that concept, then we can go for machine learning. I think.
Yes, it's
It
fine.
will take time.
But it will take time, but certainly even if whatever accuracy machine is going to give, it certainly we are not going to discuss with presently. If robotic machine we are going to develop which can be dealt, just we discuss like the doctor, then it's fine. But simple machine learning models that presently we are developing, if someone is having some severe problem at particular instant, whatsoever accuracy of our machine model is there, generally he is going, or he or she should go to consult the medical practitioner physically, and that we all do. Then how our machine learning model will be helpful, and in what type of diseases? As I said, we got some fracture, then certainly we have to go for surgery, whether it is robotic surgery or something. If we got some wound or some accident, we will be going for that. There is no need of machine learning model or some predictive, as you said, okay, after that we can have more accuracy and more accurate predictions. So, but even if we are having those type of machines, certainly we will go to the hospitals. We all will agree with that. If we have some heart attack or cardiovascular disease and we are facing critical problems, certainly immediately we will go to the hospital. So when symptoms are clearly visible, we are going to consult. But in all these type of diseases and in all these type of cases, symptoms are not just arising on that day. If someone is having some cardiovascular disease, some heart attack, something like that, symptoms would have been started from last 1 year, last 2 years, last 3 years. Do you agree with this? So for this type of diseases, rather than predicting what have occurred to us on vital symptoms, we need the models which can predict future outcomes or future vulnerability corresponding to any disease, corresponding to any person, depending upon the symptoms that are presently you are having or the symptoms that may change, for what type of diseases you are vulnerable. Or second stage will be whether it is early stage of some disease or not. Certain type of predictions are more fruitful for us, and people will go to consult your machine learning model and tool in much more efficiently, and believing that if we are having, because when we are having early stages, we are not going to go to consult to the doctor. But if you are having certain machine learning models, okay, you go to this machine learning model at the age of 40 or at the age of 35, or you are overweighted, and if you are feeling exertion, running only 100 meters, going up to the stairs, you are having too much sweat, and so on. So generally what we should go, okay, that's why we are having sweat. But maybe your lungs are not functioning properly, as someone said. Maybe your cardiovascular muscles are not functioning properly. Maybe you are having some other problems. If we are having machine learning models that we are going to just enter our query-based symptoms. Query-based symptoms, you all know, whether you are having sweat while going 100 meters, whether you are having some severe breathing after going down or up to the stairs and so on, whether you are feeling exerted after doing some work, whether after doing 30 minutes work you are getting irritated and roaming here and there, whether you are not able to focus, whether you are not able to digest whatever you are eating, even if you are eating very, very less oil foods, etc., etc. We can simply enter these symptoms, and based on those symptoms, if we can find some early predictions or vulnerability predictions, then that is more fruitful compared to if clear symptoms are there, then predicting diseases, because that is not the appropriate prediction. That is disease diagnosis. That is not prediction.
Yeah.
If we are having clear-cut symptoms, okay, this is happening, and your disease is at severe stage or clearly visible stage, then it is simple to develop those type of model. But the complex is to develop the models when symptoms are of early stages, that are not very clear symptoms. If we can build models on early symptoms or early different type of integrated or multimodal symptoms, so that vulnerability corresponding to different type of diseases, hereditary, maybe chronic diseases or whatsoever, if early stage predictions could be done, then that is more fruitful compared to disease diagnostics after the symptoms are clearly visible. I think you all will agree with this.
Yes, sir.
If we are going to have, okay, we are having severe pain in left side of our body, our BP is high, some blocking is there, then it's diagnosed that you are having certain stage of heart attack. But at that time, machine learning model will not suffice. At that time, some medical practitioner needs to be consulted, immediate management should be done. What is fruitful for us that we avoid, if we can build certain models which majorly based on query based symptoms, secondarily based on some vital parameters, BP, sugar, etc., that we can diagnose on our own by simple machines, fever, routine chart, etc. This is second type of symptoms which can be directly accessed by any person sitting in home or sitting in office. Third level of diagnostics symptoms are if we are going for normal type of CT scan, ultrasound, etc., and we are getting some glimpse or X-rays and we are getting diagnostic, we are fetching those systems. Next level is that we are going to get more advanced diagnostics in terms of signaling diagnostics, imaging diagnostics, etc. And after integrating all these things, we can predict something. But the machine learning model that is going to make early predictions for vulnerability for different type of chronic, hereditary, or any type of infectious disease, or any type of phenotype or genotype of disease that is going to cause some vulnerability or early stage predictions, that are more fruitful and that are more usable to anyone compared to diagnostics of at any time of prediction. So one, we need disease prediction in this type. Then what we need to predict? Certainly what we need to predict? Vulnerability to what type of diseases depending upon present symptoms. What type of diseases are on early stage that we may have. What type of diseases that may be on secondary level or tertiary level, and so on. We may have predictions or predictive model like this. Whether these type of prediction will be sufficient for us? Yes, we build a model. We found some, we are having some data in Excel sheet or something like that. Depending upon those symptoms, let we have some medical practitioners comment, okay, if these symptoms are there, he is prone to level 2, level 3 of disease or early level disease, and so on. Will that be okay, or some secondment needs to be done by expert persons? Anyone?
I think the data is not sufficient. We will always need an advice of an expert person.
Yes, I also agree with this, and I am also of this opinion. predicting some agricultural data, some fire predictions, something else is okay. We can have always an alternative, or if something is wrong in our data or on a prediction, that will be fine. If additional symptoms we are going to have at some point of time in other applications, whether they are financial applications, whether they are security applications, whether they are agricultural applications, where direct human risks are not involved, there we can proceed always by the standalone research done by different researchers or some authentic data sets. But whenever we are going to start our research in health sector, I always suggest that we should always involve, or if directly we are not able to involve, we should always at every stage do secondment by some expert. Then secondment for what? First secondment that we need to done is at the data preparation level. Okay, what are various symptoms? If in general we are going to develop some model, there may be two type of predictive models. One is generalized, that is very complex. Generalized means all type of symptoms that a whole body checkup that we say that a person can have, we may have all those symptoms, but can we build an table model which takes as input all these symptoms and gives us prediction for all type of diseases that we may have at early stage and we may have at advanced stage? It's little bit complex. Do you agree with this? Very high dimensional data it will be. If you will go for anemia disease, 271, 270 symptoms based on signaling only will be there. So will it suffice to do that? Yes, if we are going to build a general model that is applicable to all types of diseases, then it will be fine. But generally we don't do it. Why we don't do it? Because in real-time practitioners also, there are bifurcations. There are gynecologists, there are heart specialists, there are neuro specialists, there are eye specialists, there are oncosurgeons, there are onco specialists, there are general physicians, etc., etc. So we should also go by that phenomenon initially. And if later at the advanced stage we can make some integrated system for that, it's fine. Always we can make integrated system. Then we should start with what type of symptoms may be involved in certain type of disease. I give an example. Let me go for arrhythmia disease, that is cardiac disease related to heart disease. Then we should consult a medical practitioner. What type of symptoms, maybe the importance factor of those symptoms differ. Some symptom is going to play major role, some symptom is going to play minor role. So can we have some recording of those symptoms? What type of symptoms are involved that may affect the arrhythmia disease or heart disease? We should start from this point of recording of symptoms. That is, what are the symptoms that are related to a particular disease that needs to be recorded? One thing is noticeable here. There may be some symptoms which may be sufficient for early stage detection. There may be some symptoms, additional symptoms, including these early stage symptoms, which may give you information for advanced stage symptom. And there may be some additional symptoms which may be visible at critical stage. Do you agree with this? What I am saying,
sir.
you are getting it? They say there are 100 symptoms that are correlated to heart disease. But out of those 100 symptoms, 10 symptoms will be visible only if you are at critical stage. Additional 20 symptoms will be visible or will be recordable at advanced stage. Another 20 symptoms will be recordable or will be visible or will be cognizable at some middle stage. And there will be some symptoms which will be noticeable at early stage. From where we should start? Are you getting my point? If we are going to do disease diagnostics,
Yes, so we can start with screening. of the stage?
Yes, early stage system. The most
Okay.
important in machine learning aspects, the critical stage symptoms are not that much valuable for us. Although the prediction will be 100% accurate if that symptom will be there. Are you getting my point?
Yes, sir.
These two statements are contradictory. If we are having top 10 critical stage symptoms, they will be certainly visible. So our prediction will be much more accurate compared to early stage symptoms and predictions based on early stage symptoms. Do you agree with this?
Yes, sir.
But generally, you will see that what we do, whenever we write research papers, etc., we show that our model based on these symptoms is having much more accuracy, 98% accuracy compared to some other researchers' findings. It's fine. If top 100 systems, all symptoms we are taking, then it's fine. If someone have predicted 85 accuracy and you are able to build a model that is predicting with 90% accuracy, your research is good enough. But I'm saying second thing. If someone is having a model with all those symptoms and including those 10 critical symptoms with an accuracy of 95% predictive accuracy, and someone is able to build a model based on early stage symptoms with an accuracy of 70% or 65%, then what will be your comment? Which one is more useful for us, for a general person? Again, I am framing my question. There are some researchers who have built the machine
model
learning.
is very beneficially, which is take 78% accuracy, because it is
Yes.
detected in the earlier stage, and we can save our 78% patient.
Yes, it's right. It's very absolute answer. Even if based on critical symptoms that are visible on advanced stage, we are able to build a machine learning model that is going to predict 100% accuracy with, say 100% accuracy. It is not that fruitful because we are predicting for those people only. We are not diagnostic. This is not early prediction. It's basically diagnostics. We are diagnosing the disease for those patients which are having critical symptoms or clearly visible symptoms. So whether you can build a machine learning model for those persons or not, they have no time for preventive action. Do you agree? If we are building machine learning models which are able to give predictions even by 100% accuracy, but by the symptoms of critical stage or advanced stage, it is not that much fruitful, because then only disease management type of activity would be done. Disease prevention type of activities cannot be initiated. Do you agree with this?
Yes, sir.
That's why even if we are able to build a model, machine learning model with early stage symptoms that are not clearly visible to us, with an accuracy of 60%, 65%, 50%, it is much more fruitful for a general person to utilize or to use this type of facility to get, because at that particular time they can take preventive measures so that that disease is not going to be at next level, or that disease is going to be totally avoided, whether it is symptomatic or early stage. Generally we are confused. I was also victim of this type of things. We started machine learning prediction model and 100 symptoms are related to that, so we take all 100 symptoms to be included in all type of machine learning model. Why? I have not seen. I have just started with Dr. Dilip Kumar Chobe. We have done some work. If we are having 100 symptoms, it is not the case that all type of symptoms are going to be visible in every case. Do you understand? If it is early stage or non-visible state, some symptoms will be readable. As stage will going to be advanced, more symptoms will be visible. It is much more valuable to build a machine learning model on lesser symptoms, that early stage symptoms, lesser accuracy, rather than building a machine model which predicts with a high level of critical stages. Do you agree with this?
Yes, sir.
Hello? Yes. So we should always try for this. Machine learning tools or predictions are much fruitful, which can make predictions, because दो कारण से, two reasons are there. Because at that particular point of time, predictions could be done, preventive actions are taken, and secondly, if for early stages without visible symptoms, it's general health are not going for routine health checkup. None of us go for routine health checkup. We all know that we, after age of 40, should go once for a year for complete medical checkup. But how many of us go for that? How many of you have gone for complete health without any symptom? Anyone is? I think none of us is going to do that. But by query based, we can make a model that is able to predict an early stage or vulnerability to some diseases, and that is much more fruitful compared to having a machine learning model that is going to predict with a high level of accuracy based on different things. Now, how to proceed for predictions using AI, data science, machine learning? As I said, first you fix your objective. If for whether for diagnostic analysis, कि MRI analysis के लिए आप machine learning model बना रहे हो, you are building for CT scan analysis, you are imaging analysis, etc., or for disease prediction, the objective should be clear. Then the prime thing is that what are the attributes, symptoms, or factors involved? So as I said, the factors are not static. Early stage symptoms will be something else. Then as soon as early stage, middle stage, and stages will be advancing, the more and more symptoms will be visible. We can start building our model with early stage symptoms, and if we are able to predict an acceptable level of accuracy model by early stage system, that preventive action in that context could be initiated, and rather we can advance it by middle level stage symptoms, advanced level system, and critical level symptoms. Then importance of attributes. As I said, what is the importance of different type of attributes? There may be some prime attributes that are highly correlated at critical stage or advanced stages, and so on, that we need to be seconded. Type of attribute, some attributes will be having some numerical values, some attributes will be having some yes no values, binary values, some attributes may be having some symptomatic or not symptomatic values, some attributes may be having depending on stages, etc., etc. And some attributes, standalone attributes, will not be sufficient to predict something, but in combination the attributes signify something. So all these should be done, but not based only on the machine learning aspect. Okay, we are going to decide symptoms from some repository only. We are going to perform these importance of attributes based on machine learning or statistical or data science aspect. No, always secondment by expert medical practitioners should be done. This special care needs to be taken when we are going to build a machine learning model or AI applications in healthcare sector. You don't go by some feature selection techniques only. You don't go by some statistical analysis only for the importance of the feature. Rather than, you should always consult, even if your machine is not giving such importance based on statistical analysis. If some medical practitioner is saying that, okay, even if it is not visible, because some outliers are there which are more critical, then we should include those features. That's why I said that whenever we are working with any data, any model, any predictive analysis, validation or testing, it always should be seconded by some medical practitioners. Okay, we have made these symptoms for this disease. These symptoms we have taken for early stages. These set of symptoms we have included in addition to early stages for middle stage. These symptoms we have included for next level. These symptoms we have additionally included for advanced level, and these symptoms we have included for critical level. This always should not be done on a static databases, rather than secondment by the specific or expert medical practitioners should be done whenever we are starting building some machine learning tools for diagnosis, for predictions of disease, for diagnostic services, or any type of healthcare services. Once we finalize it and seconded it, then data acquisition is most important thing. Then query based symptoms can be easily recorded, no problem. Whatever query some patient or some person is given, query based reply, that is almost accurate. if they are not much illiterate or they are understanding the query. Then second type of data acquisition is from imaging or different type of imaging diagnostics. Third type of data is signaling diagnostics. Fourth type of data is any type of multimodal analytics be integrated and acquire related to data depending upon these systems. And secondment of these type of data, whatever we have collected by querying the symptoms, by imaging and so on, whatever we have recorded, it should be always seconded, because certain outliers should not be there, missing values should not be there. If some missing values are there, how those missing values should be handled? It should not be handled in traditional way as we do it by machine learning experts. It always should be consulted with medical practitioners. Okay, whatever missing data corresponding to some symptom we are having, we are going to manage it like this. We are going to substitute these value like this. Whether it is valid or not, this validation or secondment should always be done by a medical practitioner or an expert in that domain, and other related aspects should be considered or taken in consideration. I think it is clear to all of you.
Yes, sir.
Yes. Now, once we did it, I am again and again saying that whenever we are going to take symptoms, always second, then your data that you have prepared will be much more valuable and clear cut for the use of building a model. Then as soon as you start building the machine learning model, at every stage, you should perform consultation with some medical practitioner. Why? Because attributes and factor and symptoms that we are going to record for different stages for vulnerability of the diseases or something, we are going to consult with the doctor. Then whatever data acquisition methodology we are going to adopt, it always, let's say, मैं एक example देता हूँ आपको. Generally, you go to the medical practitioner and you say that we are going to record the BP, blood pressure, etc. by electronic machine or manual machine, that is mercury-based machine or electronic machine. In 99% cases or 100% cases, you will find that your medical practitioner will say it is much better to record your BP or other symptoms by mercury-based BP machines rather than for electronic machines. Do you agree with this? Hello?
Yes, sir, audible, sir. I think time is also going to be over, sir. Only 3 minutes.
I am done.
Yes,
fine, because this all of your things
yes,
are known.
yes.
Then acquisition, in whatever methodology we are going to acquire the data, that should be clearly mentioned. And okay, if you are recording it by the electronic devices, take average of 3 times of recordings, then fetch that data. This type of caution should be taken. If you are recording it by mercury-based analysis, then it's okay, you are going to fetch it. But generally, doctors say that if you are going to do it by electronic machines, take 3 or 4 or 5 readings after 2-3 minute gaps, take average of that and then fetch it. So with these type of practices, we should introduce. Then data pre-processing in varied domain, the different type of multimodal attributes that I always said. You start your building model by early stage symptoms, then include middle stage symptoms, that is multimodal, some imaging based data, then signaling based data, then high level contrast data, imaging based data, and then others neuropsychological or physiological data you are going to integrate. And integrating by those attributes and refining those attributes which are more important, not only by the machine diagnostics rather than with medical practitioners also, then you finalize your integrated attributes and deriving the attributes from different diagnostics outcomes. If you are having MRI, and module will be there which will be deriving the attributes from that MRI imaging and will be fetching to your model, and that will be, then you will be finalizing your attributes. And finalizing, after finalizing the attributes, always secondment should be there. And thereafter, accessing the computing needs and importance factor of various attributes, you can build your model depending upon computational complexity and other aspects. What is the objective of machine learning model to build? Accordingly, decide feature selection. Accordingly, pre-assess the type of models that may be fit to the, if you are having type of symptoms, what type of value different features are having. You can plan your model, whether you have to go for neural network based model, whether you have to go for statistical model, whether you have to go for probabilistic model, whether you have to go for deep learning type of model. This all needs to be accessed primarily based on your symptoms and type of data that Those symptoms have been recorded, along with what type of computational facility for predicting the models or other things you are having. And for model selection, you can use brute force approach. Whatsoever model you know, you apply it and find out the outcomes. But always it is better that you should know some prior knowledge for which type of attribute, which type of prediction models are best. And thereafter you build your model, test it, validate, and generalize the model after secondment. The one thing that needs to be taken in consideration, whatsoever step you are doing after training the model, building the model, whatever test you are performing and validation, a blind test by some expert medical practitioner should be done on same test data. And if your test accuracy and blind test accuracy are matching up to an acceptable level, then only you generalize your model. Otherwise, go for some corrections or performance improvement or optimization by various methods for your model. And what type of model one should choose to build? Any type of model you can choose according to your need, but it should be always blind tested by medical practitioners whenever you are building some machine learning model in context to healthcare. Then what type of model one should choose in general? We should not go for complex model. We should start with simplest model. If our simplest model is able to solve our predictive need, our objective, that is enough. You need not to go for deep learning model. Generally, we know that deep learning is very popular, then we are going to use certain type of, no. You should start with the simplest model, statistical model, etc. if it is going to fill your needs. Or models you can decide depending upon your symptoms that you are going to use for different level of predictions, early stage prediction, mid stage predictions, etc., etc. We should not go for complex models. We should start from easy going models with lesser attributes, and with complexity should be increased only if it is required based on symptom or multimodal type of feature integration. Okay. Then thank you. As per time, as our host has said that time have been done. Please explore and start, because it is going to have really very good impact on society, and start providing solutions from BTech level, MTech level, or research level, or faculty level. Any queries or suggestions for me? Audience?
Participants, please, if you are having any kind of query, you may ask him, sir.
Sir, it would be very grateful to talk with you and interaction with you. Thank you so much, sir.
Thank you, ma'am. Thank you so much. Thank you so much. So
Okay,
now,
no question from your side?
so we also take a pledge that we will be exploring and start providing solutions by using AI, data science, machine learning tools for society, especially in the fields like healthcare, where we are facing much more problem and solutions are highly required. Thank you all.
Sir,
Thank you so
excuse me,
much. Yeah, sir, ask.
sir, on which field, on which diseases you are currently working?
Presently, we and Dr. Dilip Kumar Chaube are working on, and he is the lead resource person or researcher in diabetes prediction. And I have started presently in arrhythmia, cardiac diseases, because certain cases I have seen in my relatives that unfortunately someone was having some symptoms, but they didn't have any attacks or pain, and they avoided it, and at random they got a severe heart attack. And when they discussed the symptoms that they were facing from last 1 year, they were really vulnerable, but they didn't consult to the physicians or heart specialists. That's why, so presently I have started working with my BTech students and others in arrhythmia disease. But you can start in neuromuscular disease, arrhythmia disease, neurological diseases, Parkinson diseases, cancer prediction, or any chronological diseases that we need to predict in early stage. Dr. Dilip Chaube have started in diabetes. Diabetic predictions are much more vulnerable, because if someone is going to be diabetic, he is certainly prone to the heart diseases, he is certainly prone to the psychological diseases, he is certainly prone to the indigestion or health deterioration problems. So he is doing very good, and if you are interested, you can start in arrhythmia also. There is a scope in early stage model building in arrhythmia or cardiac diseases, in mild level and advanced level. And in early stage predictions, you need not to include the symptoms related to EEG or electrocardiogram, etc. Even if you are having electrocardiogram symptoms included, you can build some more accurate models for that. You can start with any of the predictions, but we should always take care of this. And as Dr. Dilip Chaube is doing much extensive research on that, he is now started optimizing the models that have been proposed by various researchers using PSOs, using genetic algorithms, or some hybrid approach. And he is going doing very well. And we can start in any disease, and thereafter we can help such type of researchers to optimize our model, to optimize our different type of models that have been proposed. So start with any disease, do it holistically. Well, yes.
So how about AIDS and hepatitis and paralysis?
Yes, it is. I say no, paralysis is also a neurological disease.
Yes, sir.
You rightly said that this type of disease needs to be detected, because it comes, symptoms arises very early, and suddenly it happens, and we have no any option other than going for predictions. You can go for this, and really it will be very useful for the society if you are going for early stage paralysis or vulnerability. Even if someone, because if someone will having attack or clotting, then only paralysis will occur. But early stage predictions, how vulnerable a person is depending upon early stage symptoms, if we can build a model, that will be really helpful for us. And you can start in that field, certainly.
Okay, sir. Thank you, sir.
I'm happy that you people are throwing such type of things. So I think that you have got something. Okay, any other question from anyone?
Yes, sir. I was saying that we have heard a lot about that AI is used for predicting heart disease and neurological disorder. Is it possible to predict each and every kind of disease with the help of AI and data science?
Yes.
Like skin diseases. These diseases.
Yeah. Yes. Machine learning model is based on querying. Whatever medical practitioner you go for, even if it is a skin disease, what you start with? They see some symptoms on your skin. They ask you by the irritations. They ask you itching or pain, at what time, what type of itching you are feeling, whether it is bloody or not. These type of symptoms they record, and based on that recording, they perform in their brain the predictions. If anything is being predictable by normal human brain, you can always build an AI model or machine learning model to predict that. Maybe accuracy is going to be more or less, but it is always that you can build a model, but you should decide to which type of model needs to be built primarily. But yes, for each type of disease prediction model, you can always build an AI or machine learning based model, because if some medical practitioner is getting symptoms in his brain in terms of input, natural neural network is going to diagnose that, and based on their knowledge base, they are going to predict. Same thing you can incorporate or simulate in any of your machine learning models. But as I say, that skin based problem, if you will be, it will be visible. Certainly you are not going to predict it by the machine and taking medicines. You will go to the medical practitioner. So that type of models will not suffice for. But if someone has built a model for early stage prediction, paralysis vulnerability, and I am sitting here for my mother, I will see that, okay, she is having less sleep, she is getting exerted in heat over 40 degrees centigrade and so on. And I am getting, yes, she may be 30% prone to the paralysis attack. Certainly it will be much fruitful for me. And thereafter getting a primary analysis or early stage prediction by your model, even if the model's accuracy is only 50-60%. We can go to a medical practitioner and take preventive actions. And that is always helpful for us. Because 99% cases for preventive actions, we don't go to consult the doctors, either by our own, or if we are asking our mother that let's go for routine checkup, you are old age, you may have some problem. So she or he is going clearly deny you, no, I am not having a problem. Why should I go to the doctor? Asking her symptom, fetching it to some learning model available online, you can predict, okay, see this, I am fetching your signals, these are showing these symptoms, talk to the doctor. And now online medical consultations are also being integrated. Every medical practitioner is going to integrate some expert to find out early stage predictions, so that they can diagnose more and more patients in lesser times. So in different ways it is helpful. But yes, all type of disease predictions models could be built for that. And next stage would be optimization. So Dr. Dilip Kumar Chaube is doing very good in optimization of different machine learning models, especially for diabetic type of disease. You can come. Anything else from anyone?
Thank you so much. Sir, I think Yabi Salas. You may ask.
Good afternoon, sir.
Yes,
Sir, I
yes,
want
any
to
other-
ask, sir, if there's any. Sir, I want to ask if there's any limitation you are working as you are working on a model. Sir, if you examine any limitations that is not required or that we must avoid to make your model more efficient, can you highlight some points about that?
No, there is no limitation. The very good thing is that whenever we are building some machine learning model, whatever are critics, we are going to get valuable critics from anyone. We can always those critic inputs and accordingly modify our models. So there is no limitation. The only limitation is that it should establish the standard of medical practitioners. Secondment should be done not only by one, a group of experts, so that you can, okay, your model have been seconded with blind test from these medical practitioners, and in live mode, if they are giving their rating, are get included in that. But certainly there is no limitation. Standards should be followed, and any valuable critics should always be incorporated in our model at any point of time, because we are going to serve the society by helping the medical practitioners, so that scarcity of resources could be compensated by our machine learning tools or models in cost effective and timely manner. That is the purpose that I have included in my slide. Anything else from any?
Okay, sir. Thank you, sir.
Any other question from
Thank you
anyone?
so much, Dr. Sudha. I think, sir, no question. And next issues person have come online. Thank you so much, Dr. Sudha.
Thank you, Dr. Chobe.
for your valuable time. Your expert talk has provided us with invaluable insights about AI, ML, data science in healthcare for disease diagnosis and prediction. You also talked about the prediction that should be done using ML like diseases, drug discovery, diagnostic services, multimodal analysis. You also informed about diseases which should be predicted at an early stage using ML technique. And sure our participants have attained a better understanding about all these topics. Thank you again, sir, for taking out
Thank you, Dr. Chobe.
your
Thank you,
valuable time to impart us with your knowledge. Thank you, sir.
Will be continuing till the time I will be able to next session, so that I could learn also something.
Yes, sir.
Thank you.
Sir, Ashutosh Mishra, sir, my voice is audible?
Good afternoon, Dr. Dilip Chaubeji.
Yes, sir. Sir, may we start?
Yeah, please.
Yes, sir.
I
Thank you,
think.
sir, for accepting our invitation.
Thank you very much.
On behalf of the institute, I cordially welcome you, sir. Sir, we are honored to have with you. We are honored to have you with us. So I'll introduce about issues person. Dr. Ashutosh Mishra is working as an assistant professor in computer science engineering department, Harper Institute of Engineering and Technology, Patiala, since 2013. He received his PhD degree from computer science and engineering department, IIT BHU, Varanasi, in 2013. He has also worked as visiting associate at computer science and statistical department at Trinity College, Dublin, Ireland. He obtained his BE degree in computer science with distinction from UP Engineering College. He has 4 years of industry experience in different MNC as software engineer and consultant. He has involved in various industry projects. He has various national and international journal and conference paper. He has guided 2 PhD and 11 MA theses and currently guiding 3 PhD and 2 MA theses. Sir, it's an honorable moment for us to have your prestigious presence in today's event. We are truly inspired by your day. I hereby request Dr. Ashutosh Mishra, sir, to enlighten our minds with his expert talk. Sir, please welcome.
Thank you, Dr. Dilip. Thank you for inviting me and giving this brief introduction about my profile. So without wasting my time, I'm going to share my screen. And 1 second, let me share my screen. Does my screen is visible?
Yes, sir. Yes, sir. Visual, sir.
Okay.
Sir, but no zooms. Yes, sir.
1 second.
Okay, sir.
Okay, very good afternoon to all the participants and the members who are presenting this session. Today, I'm going to discuss about the topic that is a machine learning method in neurodegenerative disorder, especially in the Parkinson disease, because this is my research area and I have already supervised in this area and PhD and ME students. So this is the agenda that I'm going to discuss in this particular session, that neurodegenerative disease, what is that disorders, definition and the types of disease, and then the symptoms. And the second part, I will little bit discuss about the machine learning, which is correlated with the Parkinson disease. So what kind of different machine learning method that we can use in the Parkinson disease, right? Like ANN model and CNN model. These are a couple of examples that I'm going to discuss with you guys. And finally, I have two case study which is related to the to published paper in the Parkinson disease and machine learning methods. And finally, we will discuss about the relevant research and the future scope that can be we can supposed to do in the coming futures related to this neurodegenerative disorders and the machine learning methods. Right. So this is a very fundamental definition of neurodegenerative disorders. Basically, it's a progressive and irreversible loss of neurons from in the specific region of the brain. So if you basically the elder persons, those who are above 60 and 65 and 70, so these particular disease, their memory, their neurons is going to be weak and they are going to be deactivated, and that's the reason several kind of disorder disease that comes into the picture, right? So these are the very fundamental and very popular disease disorders for the neurodegenerative disease, like Alzheimer's disease and their other dementia, Parkinson disease and the PD-related disorders, and prion disease and motor neuron disease. So one of the very recent example of this Alzheimer's disease, if you guys are familiar with the great actor Dilip Kumar, the film actor Dilip Kumar, he was suffering from this Alzheimer's disease, or you can say dementia, since 10 to 12 years. And I think recently he passed away due to this disease, right? So what is current scenario of this neurodegenerative disease? First of all, it's affect millions of people in the worldwide. That is things, and the Alzheimer's disease and Parkinson. These are the most common neurodegenerative disease now these days, right? So as per the record by American Parkinson Disease Association in 2021 report, there are total 1 million Americans living from the Parkinson disease, and more than 10 million people are suffering from this disease, Parkinson disease, around the world. Right, and they are estimating in around 1.2 million people from the United States that will be going to suffer from this Parkinson disease by coming 2030. Right, so you can just see how severe this disease is actually. So that's the reason I want to discuss this. Now, if you go for the Parkinson disease, there are several definitions, but a very basic definition is that it's an age-related degenerative brain's condition, meaning that it causes the part of your brain to deteriorate, right? And it is what is the difference known causing of these slow movements. The person who is suffering from this disease is having slow movements. They have a tremors, balancing problem in their body, but much more definitions are available, symptoms are available, right? And a few things are this is some of the disease, some of the this particular Parkinson disease is also inherited. So these are some kind of genetical issues is also one of the reason for this Parkinson disease. So well-known symptoms for this particular Parkinson disease is loss of muscles controls, right? But most of the researcher and the medical persons, they have identified these days that this is not basically a fundamental reason, or you can say the basic reason, that is loss of muscles control is a symptoms of Parkinson. So lots of many other research has been found out, and lots of other symptoms have been carried out. So if, in terms of medical terminology, there is another definition of Parkinson disease is a neurodegenerative disorder that affect predominantly the dopamine producing. That is a kind of protein, right? Amino acid dopamine, and that will affect the brain substantial nigra. This is basically affected. This is going to degenerate your neurons. If you got affected, the specific area of the brain, the neurons which is present in that particular area is going to be deteriorates, right? So simply, if you talk about what kind of people may have experience for the PD, they have a tremor problem basically. They have a tremor mainly at the rest position, and they are described as pills rolling tremors in the hands, right? Then they have the bradykinesia is there, the limb rigidity is there, gait and balancing problems. See, these are the very basic fundamental, you can say the symptoms of a Parkinson disease patient. These are very fundamentals, and now these people are working in each domain, in each section of this area. People are working to identify the reason and cause of this particular disease. So basically, Parkinson disease has been categorized as two different impairments, actually, motor impairments and non-motor impairments. So in the first section, in case of motor impairments, the person is have a symptoms of bradykinesia, hypersalivations, postural imbalance, tremble, muscular rigidity, walking difficulty. They have a walking difficulty, freezing of the movements, right? So these are all motor related. These are all motor related symptoms for the Parkinson disease. And in the other aspects, for the non-motor related symptoms, so they have the person which is suffering from the Parkinson disease, they have cognitive issues. Their analytical power, reasoning power is going to be suppressed due to this particular disease. Then they have a sleeping problem. Then the whole night they are not going to sleep because they have a very sleeping disorder, means kind of breakage in their sleeping. After 2 hours, they are get up and then again sleep, then again get up like this. So this kind of disorders are present in the case of non-motor symptoms. Then mood disturbance, most of the time the mood will be always disturbed. They are only most of the time upset, this kind. Then they have a gastrointestinal issues. They have a problem with the gastric also, sweet and olfactory disorders, and anxiety and depression. And finally, you have a different kind of pains in their body, basically the muscular pains that should be available in their, say, body symptoms. So these are two different category, and different research are going on in all this. These are not simply terms like cognitive and these are all different research area people are working for the case of Parkinson disease, right? So if you talk about the motor related symptoms, so you can see we have a bradykinesia where people having muscular weakness, but it happens because of the muscle controls, and there is no actual loss of the strength. So it's strength loss is not there, but they have a muscular problem in their body. Similarly, if you talk about a tremor, then both of the cases, they have rhythmic shaking of the muscles, even they are not using. Sometimes you are sitting in the chair, and if you are sitting on a bed, then automatically the body will going to be rhythmic shaking by the muscles, and it is the most commonly symptoms of the Parkinson disease. And around, as you can see, 80% of the Parkinson patient they are having this kind of symptoms, tremor symptoms, right? Then they have rigidity. So in this case, they have a lead pipe rigidity and cowbell stiffness that are common symptoms again for this particular Parkinson disease. Now, the posture problem, or you can say the walking gait, these are the another, and these are the most commonly symptoms for the Parkinson disease: unable postures, unstable postures, and walking gait. The slow movements and the stiffness of the Parkinson disease, such as hunched over the stop stance, and this is usually appear as a disease get worse case. When the disease goes into the worst case, that is the problem comes into the picture. Because most of the time, if you are not thoroughly identified the Parkinson disease, internally your body is going, the patient body is going to be deteriorate, or that finally this kind of symptoms come into their body, right? And now also in addition, it is visible when a person walk because they will be use shorter stuffing strides and move their arms less while moving while walking. It's a usual tendency to a person to move their hands, right? But if you see the Parkinson persons, they are going to walk in the street, but their steps are very less to cover a small distance. They are going to use number of steps. That is small step they are going to consider, and while moving on those steps, they are not moving their hand. Their hands is not moving. So this is again one of the symptoms that can be identified. The person is having the Parkinson disease. Some other motor symptoms, as you can see, this is the blinking less. Often, this is used for reduce the control of facial muscles. So their facial muscles, the elder person facial muscle is going to be collapsed when they are going for this kind of motor symptoms, right? Then they have another micrographia. This is again happens when the muscular control problem is having to a particular patients. Then drooling is another kind of symptoms that happens because of loss of facial muscle control. Then they have a mask-like facial expression that is also known as a hypomimia, and this means the facial expression changes very little, not at all. That means if the person is trying to laugh or you're trying to in sad mode, the entire face is not going to express their facial expression. Some part of the face, this is going to be affected from this particular disease. So this is again the symptoms for the motor symptoms for the PD patients. Then they have another kind of, that is throat muscles problem. Again, it is increased to the problem like pneumonia and choking. So this is in the older person having these kind of symptoms. This again affect their PD problem and all. Then they have a soft speaking voice. Most of the patients, they have this happens because they are reduced muscles, right? Now, if you talk about the non-motor symptoms of a particular Parkinson disease patient, so as you can see here, one is the autonomic nervous system, right? So this includes orthostatics, hypertension, low blood pressure when they are standing up, right? And constipations and the gastrointestinal problem, urinary inconstitution, and the sexual dysfunction. Then the depression, loss of sense of smells, then the sleep problem. All these are the non-motor genetic, and these need to be identified early stage so that at least you can give some kind of prevention. You cannot provide any kind of medicine for that at the time being, but at least you can identify prior to the Parkinson disease patients using these motor and non-motor symptoms, which is physically available. It does not require any medical checkup. You can physically identify those kind of stuff, the behavior. So these are all common. Just now I have discussed. These are same. I have just summarized all those in these slides. So when we talk about the diagnosis of this Parkinson disease, there are currently no blood and laboratory tests to the diagnostic of this particular Parkinson disease. This is a very unfortunate thing that the globally entire world is affected by this disease, but still there is no permanent cure still available, and millions of dollars have been already spent for this particular research area, but there is no concrete solution till date. Only the doctor are usually diagnose the disease by taking a person's medical history, performing the neurological examination. That's all. And if the system improves after starting to take the medications, it's another indicator that the person is having the Parkinson, right? Similarly, the people with the Parkinson-like symptoms that results from other causes, such as multiple system atrophy and dementia with level bodies, are sometimes said to be a Parkinsonism. So it's just like a different kind of another extension of the Parkinson, which have entire diverse environment. So if you talk about a little bit treatment which is available in this particular disease, so you can see there are the medicines for the Parkinson disease, as you can see. So medicine can help to treat the symptoms of the Parkinson by increasing the level of dopamine in the brain. So this particular dopamine is responsible. It's a main culprit, or you can say, for the Parkinson disease patient. So by using medicines, you can simply you can increase, but you cannot say that we are going to cure your Parkinson disease, right? Because there is a continuous degeneration of the dopamine is happening in the mind. You are just balancing those stuff, but you cannot overcome that, right? Similarly, they're having an effect of other brain chemicals such as neurotransmitters, and which transfer the information between the brain cells, right? Then helping the control for the non-movement symptoms. So these are all, just now I have discussed non-movement symptoms. So you can, by using those medicine, you can control the system, right? But in some cases, in the higher severity level of the deep learning, Parkinson disease, doctors are also using this deep brain simulations, right? For the person which is having Parkinson disease and which do not respond well from the medicine, the doctor may recommend for the deep brain simulations. This is a very novel area. The people are trying to work, but there is no fruitful result till date. So during this surgical procedure, what will do? The doctor will implant the electrodes into the part of the brain and connect them to the small electrical device implanted in their chest. But it is not till date in India. It is not very feasible in India. But other European countries, the doctor are approaching this particular method of deep brain simulations. Then other therapies are physical occupation speech therapy, which will have the gait and voice disorder, tremor and rigidity, and a decline in the mental functions. Then the healthy diet to support the overall wellness, exercise for the strengthen the muscles and improve the balances, flexibility, and the coordinations. Then the massage therapy to reduce the tension, yoga, and then other to increase the stretching and flexibility of the. That can be feasible solution to at least control a PD patient, right? So when we talk about the second part of this lecture, so this is machine learning. So you guys are familiar with machine learning. So I just give you the glimpse of this machine learning and how this machine learning we are going to use in the Parkinson disease. So this is a very fundamental concept about the machine learning, that we have a several set of input raw data, and we have a pre-existing algorithms are available for the machine learning, right? So you are going to put those raw data and to the machine learning method, and they are going to process it. And we have some convention to whatever the raw data is there, you have to process some training data, and then finally you can test the model with the testing data, right? So when you have this model, you can find the output of this particular model. This is a trained model. And whenever you give any for physical input, that external input, based on the property, based on the model accuracy and all, you are going to identify what kind of input image it is that is going to be input as an input to the model. So this is basically a standard definition for the machine learning, and this is nowadays very common. I'm not going to discuss because these are things very people know this supervised learning and unsupervised. So this is our ANN model. So why we are using this? Where we are going to use this ANN model actually basically in the Parkinson disease. If we talk about this, so we have several. In the Parkinson disease we have several data sets. So in data sets we have several features of the patient, different features, motor features, non-motor features. All those features are available for each patient in your data set. And in this case, you are going to put all those input values in your NN model with their some weighted value, right? And based on the different weighted value, the model is going to be predicted whether the patient is having PD or not, right? So in this case, we have all input layer, hidden layers, and different. You can have multiple hidden layers, and this can have the finally output. So the output of the ANN model you can find with this particular expression. This is yi is the output of the model, which is the weighted sum of the input values, and this is theta is your activation function, which is required to give the higher accuracy of the model, right? There is another concept because this convolutional neural network that people are using now these days in Parkinson disease. You can find most of the research paper people are working this model. The reason is that because this model basically supports most of the image files. So the different image of a Parkinson patient brain image, especially fMRI image, you can say the MRI image. Then we have a different PET image. All those images are there, and those images can be only recognized, can be only perform better performance using this CNN model. So in this CNN model, we can give the several images of the patient, the Parkinson patient, like MRI image or fMRI image as an input value to this convolutional layer, right, which is having the activation functions, right? And after the next state, when you give all those images in this particular, which is a form of pixel actually. So you are based on that, you can have a multi features which is not required for the process of the CNN model. So you can use this polling layer method where you can simply remove the unnecessary image which is not having major contribution for this the feature selections, right? So once for this you can simply reduce the dimensionality of the features by using this polling layers, and then you have a series of convolutional and polling layers where you can use the flatten methods. This flatten method is basically convert your two-dimensional images into the one-dimensional images, as you can see clearly. And this will again send it back to the different fully connected internal hidden layers are there, just like other ANN models. And based on this model, you can find different output layers here. Right? Different class. These are all different classes of the output layers, right? This is again, it is a little bit more generalized form of this CNN model. As you can see, these are all different images. You can assume that these are the brain images of a PD patients, and you are going to data pre-processing of this using different standard method like standardization, normalization, outlier detection, and all. And you have to select different model selections using this LXNet, ResNet, based on the requirement of the image and based on your what kind of output you are expecting. You can select this particular model, and again the same process it will perform by this CNN model, and finally the output will come like you can see different classes will be generated by this particular model. And once the new image will come as a testing, you can simply classify whether that particular person is having PD or not using this particular classes that we have generated from the CNN model, right? So if you talk about the research point of view, you can see this is very interesting. The reference I have taken from one of the journal. See here you can see the different kind of Parkinson patient have a different kind of symptoms. As you can see, they have a voice problem, gait problem, handwriting problem, and these are MRI images, SPECT images, right? And PET, CSF. These are all different kind of. You can say the PD images are a different data set which is available for the diagnosis of this particular disease, and what are the different machine learning method that has been used till date. So you can see the SVM neural net. You can say this is your ensemble learning, KNN, regression. All these kind of machine learning method has been used. And as you can see, the first bubble of this particular diagram, this is having 32. So that means for the voice recognition of the PD patient, that they have used support vector machine with the 32 research papers till date. I mean, there's some duration for this, so 32 papers. Similarly for the guide, and you can see it's if you go to the MRI images, again, SVM is a higher priority till date. But the rest of the case, you can see the bubbles are very small, and you can see there is not much work has been done by using this particular SVM for the PAT, CSF, and all kind of data sets. Similarly, you can see down, you can find again the naive-based decision tree. These are having 9-4 research work that has been done corresponding to the voice, guide, right? Yes, right. So these are the relationship between actually what kind of machine learning model that has been used for the different type of symptoms or a data set which is available for the PD patients, right? The reason is that because most of the symptoms, motor and non-motor symptoms are responsible for the predicting of the PD patient. But now these days, people are working basically in the MRI data sets, PET data set, and fMRI data sets. These are all the medical related data set which is available for the PD patient, and these machine learning are not very much compatible for their pre-processing. So that's the reason heights, convolutional neural networks, and all these deep learning methods comes into the picture to process such kind of MRI and fMRI data set of this. So this is one of the case study I have taken that machine learning. This paper has been published in one of the reputed journal, Machine Learning Ensemble for Parkinson Disease using protein sequences. This is one of the case study. Recently 2021 paper, and it is our work actually. It is published in the research paper in 2021. So the most challenging issue in this diagnostic and treating the neurological disorders is the gene identifications. So different genes are responsible for the PD. So gene identification is very important to identify for the what kind of different composition which is available or physiochemical properties are available in the genes, which is responsible to enhance the Parkinson's disease, right? Then the classification of the genes that causes and initiate the genes leading to disease with neurological disorder like Parkinson's disease, and it's a grave challenge in the biomedical research these days. So this is the architecture of this proposed work. They have taken the project. We have taken this protein sequences of the genes, the pre-process the data, and the free feature extraction has been done for the hydrophobicity and the amino acid composition, which is available in a particular genes. Then we are using the training and testing by different machine learning and ensemble learning method. And finally, the proposed output is signify that whether the particular genes of the patient is having PD or not. So this is the data sample actually for the, you can see there is 38 for each particular gene. These are all the genes which is responsible for the PD. So these are all genes, and in each genes we have a different kind of hydrophobic values up to H1 to H38, and similarly we have a amino acid composition which is available in each genes. This is around A1 to A20, that is 20 total attributes are there. So based on those data set, we have classified by using machine learning and ensemble model, we have classified whether the person is having which genes is highly responsible for the PD and non-PD. This is the methodology which is adopted in this method. So I don't want to discuss this. So see, this is the performance of the different. You can see the model which we have used, different random forest, ADA, GBM, NIFACE, neural network. These are 10 different machine learning methods have been used for the same data set. And these are the output that you can see in the screen, comes into the picture. So based on that, in the proposed model, we have gone through the ensemble method and deep learning method, and it has been found that our proposed model, as you can see, this proposed model is having high accuracy. Their ROC curve is, you can see this ROC curve is very close to the 80 or 90% accuracy compared to the other machine learning methods and the different deep learning method like MLP and LSTM. So the proposed model of this particular work has been highly effectively give the output that whether particular genes responsible for the PD or not. Then there is another paper that is again published in 2021 or 22. This is our PD genes identification. And again, it's an important role to improving the diagnostic and treatment of the disease. So this particular method is use the neural network based ensemble model for identifying the Parkinson's disease genes actually. So the additional concept that they have used in this particular proposed work, they have used several autocorrelation method for the feature selection. Here you can see the Gary autocorrelation method and Moran autocorrelation method and normalized Moreau-Brotto autocorrelation method has been used from the same sequencing of genes data, right? And those data shall be then based on those features factors, we are going to get gene negative sets of the, and then MA negative sets and the NA negative sets of the data sets, right? And then we are applying different, again, machine learning methods. And finally, based on the multi-voting method technology, we have finally conclude this with the ensemble method to give whether the particular genes is having PD or not. So if you want to go with the detail of this particular work, you can simply go to the reference, you can find it. And these are all data set that has been used for different genes in this particular work. Right. So main outcome of this work was that is the basis of various performance measure and results from the proposed ensemble method show the enhanced performance compared to the state of art work. That means in the previous as you can see the second point, different machine learning method is already used, and based on that we have used our proposed model give the higher accuracy and ROC to identify the genes which is responsible for the PD and non-PD for the given data sets. So, and these are the different research so far. People are working in the neurodegenerative, basically in the Parkinson, using machine learning method, as you can see. So these are the method PCA plus fuzzy, KNN, SVM and rotation forest. Then they have used SVM, KNN, SVM. So you can see in this small screenshot, the SVM is having higher priority here. And that was resembled in the previous bubble slide, right? So you can, and what kind of data set they are using, the vocal features, again from the UCI repository. Then they are using the gene expressions, topological features, and then again topological features, human protein interactions, which is responsible for the PD to identify whether the person is having PD or not, right? So this is very interesting graph. Again, you can see what are the research work people have done till date in this particular area of PD and PD and the number of publication in the last 2008 to 2019, as you can see. So you can see we have a different diagnosis of the Parkinson disease. There is a one concern. Then the prognosis and monitoring the disease progression, then predicting the response to the treatment, and there is a rehabilitations. Again, these are 4 different category of Parkinson-related disease that has been categorized, and the people are publishing the work where they have done a lot of research. You can see it's drastically changed from 2008 to 2019. So you can see that the blue shaded portion is basically the diagnosis process. The people are very much emphasized to diagnosis the PD patients by using this kind of research works. Then they are again, the majority is again, second is monitoring the disease progression, which is very much required, right? So diagnosis and monitoring, this is the major concern because we don't have any treatment, right? So this is the main thing, that how early you can going to predict and how much accurate your prediction is there based on several methods. That is the main aspect of this PD. Right. Then finally, what will be the response? What kind of treatment you are giving for the motor, non-motor, or physically, whatever the treatments you are giving? What are the different response? What is the response of those treatments for the PD patient? Is again is a major concern. Then we have again the rehabilitation. This is the things that people are looking to. You can see this is a good actually analytic statistics shown by this PD paper. Then if we talk about this special area of the PDs and how much people are working in this particular publication point of view. So you can see the guide, the problem, the person, PD person which is having guide problem. Most of the researchers, they are working on this particular area, and the paper has more than 300 from the last 10 years. Again, for the tremor, dementia, limb movements, and like this. As you can see, the very less work has been done with the circuits and the emotions and the handwriting. So this is for the current researchers and the person who are going to interested to work in this particular area. They can focus this particular emotions, handwriting, and sleep topics because very less work has been done in this area. And the cognitive aspects of this is very, very important. And you can find still people are working on this area, the cognitive aspects of a Parkinson patients. So this research is going to be increased, but these are a very focused area because these are already existing. These are already existing, but we should focus on this particular area, the emotions and the cognitive aspects of a Parkinson patients. And this is the methodology. I don't want to discuss this. Now, if you talk about the geographical distribution of Parkinson disease incidence in the age group, right, as you can see here. So if you talk about socio-demography index, so in 1990 to 2019, the number of PD patients that is going to be increased with the different range of ages, as you can see here in diagram, right? So this is again is a quite matter challenging, and we should need a focus on these particular cases. Similarly, for the other part, basically the European country, their people are very much suffering. So this is one of the research article. People should work on this area. What is the reason behind it that the European countries are much more suffering from the Parkinson disease than that of our Asian countries or other countries? Because the loneliness and of the elderly persons, the people are isolated. They have an individual life. Their social life is very much isolated. So there could be a reason so that the persons are suffering from the PD and all. So these are all statistical analysis that has been done by the different researchers, and that what are the different area of the country the people are suffering from this PD in 2019 to 1990 to 2019. So we should analyze such kind of graph, and we should focus on this area and promote the researchers to work on this area. And finally, you can see these are the different method of machine learning that has been used in terms of number of publications. So, artificial neural networks, ensemble learning, SVM. So you can see the clustering and Bayesian models. These are the least models which is going to be work for the classification, or you can see the categorization of the PD patients. So what are the challenges that we are expecting? That the main challenge is that the early diagnostic and the prediction of the PD patients. Then the societal awareness is very much mandatory, especially in India, about this, because we are not bothering, we have even psychology here. We are very much, people are thinking about the elderly persons, right? Then we should make a monitoring device so that we can monitor their day-to-day life of the PD patient. Resource availability is again a major concern, and we should awareness of the research funding so that we can work with this kind of area. Future scope that we should promote. This is totally interdisciplinary research. It is not an individual domain. So it is totally interdisciplinary research, and we should promote that research. And we should write good projects to grant, because in the national and the international level also, people are, lots of international agency, they are very much open for the granting in this particular area, right? So we should work on this, we should focus on this area also. And these are the useful YouTube link that you can find some good information about this PD, the references that I have taken from this. So this is all about my brief talk about this PD, and if you have anyone interested in this area, please contact me. This is my email ID. Thank you very much. Any question, any query? Chauvin?
Any question? Yes, sir. Participants, if you are having any question, please ask from sir. You are having 1 minute time, not more than 1 minute. So ask, you may ask based on this topic. Participants, any question? Okay, so thank you.
Thank you.
Thank you so much, Dr. Astos Misa sir, for your valuable time.
Yeah, thank you,
Your expert talk has provided us with invaluable insights about MLDL techniques for prediction of neurodegenerative disorders. You informed us about symptoms and treatments of Parkinson's disease. You also talked about why and how you use different ML algorithm like SVM, random forest decision tree, and ANN, CNN model for brain image classification, and various ensemble and autocorrelation method to predict the Parkinson's disease. I am sure our participants have attained a better understanding about all these topics. Thank you again, sir, for taking out your valuable time to impart us with your knowledge. Thank you.
Thank you, Dilip sir. Thanks for participant for your time. Thank you very much.
Thank you.
Thank you.
So, participants, our main lecture was started by 4:20. So right now I think it is only 4, not even 4. So I may start, okay, and we will start valedictory before. Actually, our time was to start valedictory by 5:10. I was going to give you very less time for my talk. So okay, before this means by 5:10 actually we have to also share one quiz to you all. 30 question will be there and you have to complete within 15 minutes. So I think I should give you how much time? I should give you 15 minutes, means 5:10, 4:55. My lecture will be from 4 to 4:55. Okay. So I think you all know about me. So my topic today, my talk will be, my title will be, I am going to share my screen. Okay. You all know about me. If you don't know about me, I want to tell you. Firstly, I also want to introduce myself, because you all know only about me. I am working as an assistant professor in IIT Bhagalpur. And before this, I have worked as an assistant professor senior in Valedictory during 13 May 2009 to 6 November 2020. I have also worked as an assistant professor in NIT Patna during 30 March 2017 to 9 May 2019. Before my PhD, I have also worked as an assistant professor in LNCT Bhopal and Oriental College of Technology Bhopal. I received my PhD from Birla Institute of Technology, Mr. Ranchi, in 2018. Okay. I received my MTech degree and BE degree from RGBP Bhopal in 2012 and 2010, respectively. I have written 2 books, also one copyright, and 59 reputed research paper in various reputed journal, conferences, and book chapters. Okay, I have also one project as a co-BI funded by TQ Collaborative Research Scheme. Currently, I am guiding 2 PhD research scholars, and I have already guided many MTech and BTech projects. Workshop, also attended many workshop, seminar, conferences. I reviewed many research papers in reputed journal, conference, book chapter, lifetime member of several professional bodies like IEEE, IANG, ISOC, SWI, WC, etc. My research areas are AI, machine learning, deep learning, data science, soft computing, pattern recognition, bioinformatics, data mining, database management system, IoT. Okay, so those who want to pursue PhD after MTech, because many are MTech students in this also. So, okay, and I'm also receiving what? Resume. So, okay, so based on this area, you may visit to IIT Bhagalpur and then apply under guidance of me. Okay, and then means okay, you may send your resume, and then when advertisement will be given by IIT Bhagalpur, based on your resume, okay, then of course at that time we will see that. Okay, so I am going to start my lecture. Okay. Are you able to see my screen?
Yes, sir.
Yeah.
Yes, sir.
Classification for healthcare. Yeah. Classification.
Yes, sir.
I'm not going to take too much time. I will also leave it soon because I have to also assign you cues. Okay. And okay. So thank you. Classification for healthcare system. Today the contents of my presentation will be classification, motivation behind classification for medical diseases, how to partition data set by using VICA. Okay. Classification terminology, machine learning, soft computing, data mining, feature selection. Okay, because I am going to implement the things in VICA, I will give little bit credit to this, demand and diabetes data set and localized diabetes data set. We will discuss little bit too, and name-based decision tree. I will not go in depth, I will try to complete. Sure, okay. So, what is classification? Okay. The grouping together of similar things into different segments based on common qualities or attributes, which is called classification. But you may tell, sir, this is also called clustering. This is not only classification. Okay. So, okay, you may also call to this what? Clustering. So, but 1 minute. Yeah. So, you may also call what? Clustering. To this term, this is not the definition of only classification from here to here. Also the definition of clustering. But see again, classification is a supervised learning method. That is, the training data has to specify what is to be learned. Okay, so where we are going to give what? Training and testing. Means based on what? Trained data. If we are planning to predict something, then this is called what? Classification. Since a training set exists, this method is known as supervised learning. Okay. In classification, the data set partition between training data set and testing data set. Okay. So we generally classify it between training and testing data set. Actually, there is no hard and fast that we have to partition only 70 and 30. This is just like when we are driving car on good road. So we should usually run 70 to 80. If you are driving bike, 50, 60. This is just like we should do it. Okay, but there is no hard and fast way. We have to do each and every time only 70 to 30. The training data set is used for what? Training the system. And testing data set is used for what? Testing the performance of the system. So if somebody will ask from you, okay, what is the performance of your system? If you have built any model, algorithm, then you no need to tell based on the training performance. You have to told based on your testing performance. Generally in classification, a set of predefined classes, and the goal is to find in which class a new object belongs to. So why we do classification? Okay, so this is the motivation behind it. Why we do medical diseases. We use classification for medical diseases. Okay, in healthcare. This is my topic, classification for healthcare system. It is well known that till some year back, physicians diagnosed the disease with experience and clinical data of the patient. By clinical data, we mean what? By clinical data, we mean laboratory test report. So, laboratory test report, somebody is wants to join. How is the permission? Laboratory test report. Okay, so laboratory test report, we mean what? Actually, it vary depending on what? Meal, exercise, sickness, stress, due to small changes in temperature, different equipment used in way of sample handling. So, this kind of diagnosis of the disease is what? Time consuming, because it is entirely dependent upon the availability and the experience of the physicians who has to deal with imprecise and uncertain clinical data of the patients. So, to improve the decision making with clinical data and reduce time consumption, a good diagnosis system is very much needed. Researchers say that even the most experienced of physicians is not capable enough to detect the disease quickly and accurately. He may require feedback from the several patients for diagnosis of a particular disease. It is always a problem for physicians to identify any disease accurately and in speedy manner. The main problem behind any misdiagnosis of the disease are stated below. Lack of communication. First point is what? Lack of communication. When patient visit to doctor or went to doctor, they does not communicate well to a physician from which disease they are suffer. Lack of experience. Patient is not go to an experienced doctor. He generally visit to what? Partial matching doctor. Lack of pathological report. Actually, well-established lab are not established in where? Small cities. They are available only in big metropolitan cities. These three are the point which which causes any misdiagnosis of the disease. So here I told you use the term training, testing, and validation. I have used the term what? Training, testing, and validation. Okay, you will see here. What is training? What is testing? What is validation? This is sometimes there is no hard and fast that you have to partition the data set between only training and testing. Sometimes you also do validation. So question arises, sir, why we split the data set training, testing, and validation? Why to validation also? Because to improve the performance of training, we go for what? Validation. We tune based on validation, we tune the parameter in such a way that the performance of the training should increase. So right now you may see the definition of training. Training data sets means to train a particular input so that later on may test them for unknown input, which they have never seen before. Okay, for which they may classify or predict, etc. This is most of the machine learning techniques like SVM, neural network, Bayesian, etc. based on. Training data set is used to construct or develop, learn, or model classifier. Okay. The training data set is used for what? Training means optimize calculation adjustment the weights for a given set of parameters in the system. Testing data set is used to measure the performance of the system. Testing data set is used for assessing or to evaluate the model performance of future data. Testing set is used to estimate future error rate. Validation data set is used to check the quality of training and to find best combination of parameters. You may see validation data set is used to check what? Quality of training. This is used for quality of training and to find best combination of parameters. Validation data set is used to select a model based on summation of picking algorithm and node settings. The training, testing, and validation are used in where intelligent system, machine learning, and genetic programming. So, we may see. So this is what for training, testing, and validation. How you may partition the data set by using weekend. So you may do it through by what? These procedures. Okay. Start Vika, go to Explorer and click it. I will do it. I'm not telling only that you have to follow this procedure. In front of you, I am going to demonstrate. Actually, we partition it manually. But when there are large number of data sets, in manually we also do mistakes. But by using tool, there is very less chance to do mistakes. Okay. So what? Start with go to Explorer and click it, or click on open file, go to filters, choose unsupervised, choose instance, click on resample. Okay. Edit properties, no replacement. You have to do it to sample size percentage. You have to just put 60 and then OK apply, and you have to do it save train. Followed by you have to do undo. Click on resample, invert selection true. You have to do OK apply. Click on resample, invert selection false. Sample size percentage 50. OK apply, save validation, undo revert, resample, invert selection. You have to do true. OK apply, save, test. This procedure you have to what? Follow. Okay. So I'm going to start Vika. 1 minute. So I'm going to start Vika. How you have to do it? Okay. Just go there. Here. Okay. You go there and you just go. I'm just doing it. Yeah, you just go there, open it. Okay. I think you have opened it. It is going to open. Yeah. Okay, I am just once again sharing the screen. Okay. So I think right now you are able to see my what? Screen. Yeah, how to partition data set. Okay. So firstly, what procedure I have told you, you have to just follow the same things. Okay. You have to just open file. What data set you want to select. Okay. Firstly, you have to select the data set. So go here there and then just suppose diabetes. This is very popular data set, PMA Indian diabetes data set, available in UCI repository. Okay, this is available in UCI repository. And then what you have to do? You have to, I have told you how to partition. Manually, actually, you do what? Wrong. But if you are going to use this tool, there is very less chance that the mistake is going to be happen. And then what you have to do? You have to go open file. You have done it. Right now you have to go there, and then you have to go to filter, and then you have to what? Choose unsupervised. What I have told you. Then you have to go instance. Okay, and then you have to go in resample. Okay, and then you have to do what? Edit properties. Double click. It means what you have to do? You are just seeing that here 768 instances is there, 980, and 980 is class including. On yesterday, Dr. Chandrasekhar Azad from NIT Jamshedpur, he has discussed about this data set. Then what you have to do? You have to do, okay, and apply. You have to do apply. Okay, and then you have to do what? Save. No, actually, okay. So resample. Once again, what I have told you, you have to just go. You have to, yes, choose file where, yes, 1 minute. Open file. You have select the data set. This data set you have to find. You have seen 768 instances, 980. From this time, from this, you are clear. And then what you have to do? Go. You have to go in. Yeah. Then you have to choose filters, and then in filters you have to go in unsupervised instance. Then resample. Yeah. You have gone there, and then you have to change the property. Okay. We have not changed here. Actually, that's why. Then you have to change the setting here. What you have to do? True. Okay. And here you have to change, because if you want to change 60, 20, 20, what you have done? 60. Okay, and then you have done okay. Then here you are apply. You may see there 460 samples have been extracted out of 768 instances. You have done okay, apply. Right now you have to save it. Save and give name what? Train. You have given name train. Okay. Right now what you have to do? You have to go undo. You have to do undo. You have seen what? 768 instances have returned back. Then you have to go where? Resample. Okay. And then you have to change the property. What you have to do? You have to do it true. You have to do it true. Then you have to do it okay. Okay. And then you have to do apply. You have seen that what? That 308 have come. Okay. Then what you have to do? You have to once again go. Okay, and then resample. You have and you have to change the property. In bird selection, what? You have to do it false. And here what you have to do? 50. You have done it 50. Then do OK and apply. You have seen that 154 have come. And then you may save it what? Validation or test. You may do anything. Okay. You have to just save it. Validation. Okay. Right now you have to, what I have told you, you have to do undo. You have seen 308 have come. Okay. And then you have to go once again in resample. Okay. Then invert selection, you have to do it what? True. You have done it true. And then you have to do okay. And here what you have to do? Apply. 154 have come, and you may do here save. And what you will give the name? Page. So like that, you may do it. And this all have been said, training, testing, and validation. In this way, you may partition the data set. I am also having localized diabetes data set, but I am not going to emphasize too much on this. Okay. So I will come back to my slide. Okay. So how to partition data set? We have seen that training, testing, validation. Okay. Then in other terms, we may also what define to finding the known target value based on the known target value in the data set. It enables us to retrieve particular things or information. This is needed without too much time. It helps us easier to organize things or easier to locate, retrieve, maintain things and information which make human life easier. Classification and regression problem are examples of supervised learning. There are several examples of classification problem. Classification of an email into spam or non-spam, prediction of cancer, gene classification into coding or non-coding, diabetic prediction, classification of transaction as fraud or genuine. Many more examples are there. There are some terminology, okay, which is famous in classification, okay, just like classifier. What is classifier? A classifier is nothing but an algorithm that is used to map the input data to a specific category. Then classification model. If you have built any model, okay, if you have constructed or develop any algorithm based on classification, to that what you call classification model. Okay. So the model predicts all paths and conclusion to the input data given for training, and it will predict the class or category for the data. Then feature. It is also called what? Attribute. It is also called what? Variable. Like that, many terms are there. Is nothing but an individual measurable property of the phenomenon being observed. Okay. Binary classification. It is a type of classification with two outcomes. For example, it can be either true or false, 1 or 0. Multi-class classification. The classification with more than two classes is known as multi-class classification. And in multi-class classification, this simple is assigned to one and only level. Okay. Then multi-level classification. This is a type of classification where each sample is assigned to a set of labels or target. Initialize, which is used to assign classifier for the class. Predict, the target for an unlabeled observation X. The predict method returns the predicted method Y. Evaluate means evaluation of the model. Okay, this is the what? Working. This is working. Training data will be different, testing data will be different. These both will be different. By applying ML algorithm, okay, on training data, we are going to get some result output, and based on test data, okay, based on both performance of this data, we are going to tell, yeah, this is the algorithm which we are going to deploy, and this means evaluation result. Okay, so next slide, same things, training, testing, everything, nothing. Machine learning, when we are going to do classification, so how we will do classification? So we are going to do classifications by using machine learning, soft computing, data mining. Okay, so term machine learning was first introduced by Arthur Samuel in 1959. It is said as a subset of AI that is mainly concerned with the development of algorithms which allow a computer to learn from data and past experiences on their own. It enables a machine to automatically learn from data, improve performance from experiences, and predict things without being explicitly programmed. In machine learning, classification refers to a predictive modeling problem where a class level is predicted for given data. So I have used two terms here. You may see here it is a subset of AI. So what is AI? You will tell, sir, it is a technology which enables a machine to simulate one behavior. What is the goal of AI? The goal of AI is to make a smart computer system like humans to solve complex problems. So what is it leads to intelligence or wisdom. It will go for finding the optimal solution. Okay. So machine learning, what it leads to knowledge. It will go for only solution, whether it is optimal or not. But AI always finding the optimal solution. So you may see in machine learning, classification refers to a predictive modeling problem where a class level is predicted for a given example of input data. Currently, it is being used for various tasks such as image recognition, speech recognition, email filtering, Facebook auto tagging, recommender system, and many more examples are there. This is a block diagram explain working of machine learning. Input data means it is going to be learned by using this algorithm. Then we will tell this is the algorithm, and for unknown data means test data we are going to give the finally output. So you may tell this is the features of machine learning. It uses data to detect various patterns in a given data set. It can learn from past data and improve automatically. It is a data driven technology. Okay, so what is the need for machine learning? Next one, what is the need for machine learning? Why we are going to study machine learning? So the need for machine learning is increasing day by day. The reason behind the need for machine learning is that it is capable of doing tasks that are too complex for a person to implement directly. As a human, we have some limitations, as we cannot access the huge amount of data manually. Okay, so for this, we need some computer system, and here comes the machine learning to make things easy for us. We can train machine learning algorithm by providing them the huge amount of data and let them explore the data, construct the models, and predict the required output automatically. The performance of the machine learning algorithm depends on the amount of data, and it can be determined by the cost function. With the help of machine learning, we can save storage capacity, okay, and we may improve the computation cost. So next, the importance of machine learning can be easily understood by its use cases. Currently, machine learning is used in self-driving cars, cyber fraud detection, face recognition, friend suggestion by Facebook, etc. Various top companies such as Netflix and Amazon have built machine learning models that are using a vast amount of data to analyze the user interest and recommend product accordingly. Okay, flowing are some key points which allow the importance of machine learning. Rapid increment in the production of data, solving complex problems which are difficult for a human, decision making in various sectors including finance, finding hidden patterns and extracting useful information from data. This is the classification of machine learning. Okay, at a broad level, machine learning can be classified in three types: supervised, unsupervised, reinforcement. The above three types of learning may be classified based on the presence or absence of a trainer. Okay, the information provided for the system to learn. These two are the kinds. Based on this, we classify either this is supervised, unsupervised, or reinforcement learning. So supervised, what is supervised? You may see here. Supervised learning means the target output values are known for each input pattern. Supervised learning is performed with the help of a trainer, teacher, or parent. You may see here examples. Okay, this is the actual output and desired output. If it is not going to match, then error signal generator is going to it is going to optimize the way. It is going to when this will not be minimized. Error will not be less until error signal generator is going to optimize the weight. Okay, so in this way, finally the things is going to be minimized. Error is going to minimize between actual and desired output. So here, who is the trainer? Error signal generator. Who is going to train the things? Okay. considering the example of the learning process of a small child, the child learns from parent at home by the teacher in the school, that each and every action is supervised by the teacher and parent. So the trainer trains the child in such a way that he works on the basis of the output, what he has to produce. All these real-time events involve supervised learning methodology. In the same way, in ANN, each input vector requires a corresponding target vector, which represents the desired output. During training, the input vector is given to the network, which results in an output vector. This is the actual output vector, which is compared to the desired output vector. Okay, if there exists a difference between the two output vectors, then an error signal is generated by the network. This error signal is used for adjustment of weight, what I told you, until the actual output matches the desired output. So in this type of training, a supervisor or teacher is required for error minimization. Second type of learning is what? Unsupervised learning. Unsupervised learning is performed without the help of a trainer. Suppose, consider the example of the learning process of a tadpole. It learns by itself. A child fish learns to swim by itself. It is not taught by its mother. Okay. So you may see here, here is not error signal generator. This is going to learn by itself. So, okay. Then thus its learning process is independent and is not supervised by a teacher. Similarly, in an ANN, the input vector of similar type are grouped without the use of training data to specify how a member of each group look or to which group a member belongs. In the training process, the network receives the input pattern and organizes this pattern to form cluster. Okay. So, okay, we will come for enforcement learning. Actually, this is a combination of supervised and unsupervised. Okay, you may see that this learning is similar to supervised learning because here the network also receives some feedback. By reinforcement learning, I mean the critic information is available, not exact information. Here, critic means less information might be available. So, actually, you will not have the exact information, but you will have information. Based on this, error signal generator is going to be minimized. The weight adjustment. It is going to minimize the error. For example, the network might be told that the actual output is only 50% correct or so. The learning based on the critic information is called reinforcement learning, and the feedback sent is called reinforcement signal. Okay, this is the block diagram. You may see here that here not written d minus y, but which was written in case of supervised learning. Okay, so here you are not going to get the exact information, but this is going to play the same role what if this block is in reinforcement learning, which was not in what? Unsupervised learning. So learning categorization based on some rule: Habian, gradient, completely stochastic. You actually some learning comes in supervised, some comes in unsupervised. You may see that Habian and competitive learning comes in unsupervised, stochastic and area gradient comes in supervised. Okay, and this is what about soft computing. So what is soft computing? Why we actually might know our short-term course title is AI and Data Science in Healthcare. So you may tell soft computing. We are not doing emphasis. Our expert lecture, resource person have not given emphasis on hard computing. So why they maybe any resource person, each and everyone has given emphasis on just on soft computing. So why we should know what is the benefit, what is the merit of soft computing, why we use only soft computing instead of hard computing. So soft computing deals with approximate model and gives solution to a complex problem. Soft computing uses a combination of genetic algorithm, neural network, and fuzzy logic. The main goal of soft computing is to develop intelligent machine to provide solutions to real-world problems which are not modeled or too difficult to model mathematically. The same is what? To exploit the tolerance for four terms you may see: approximation, uncertainty, imprecision, and partial truth in order to achieve close this balance with human life decision making. Okay, so what we mean by approximation? Approximation means that the model feature are similar to real one but not the same. Uncertainty means the people are not sure that the feature of the model are same as that of the entity. Okay, and imprecision means the model feature are not the same as that of the real one but closely resembling, but means closely to them. This is the definition of all these keywords. So soft computing deals with approximate model and gives solution to complex problem. Here I have written the reason why we use soft computing generally. This is the reason. Okay, and why you don't use hard computing? Why soft computing based on hard computing? Soft computing can deal with ambiguous and noisy data. Okay, whereas hard computing requires exact input data. So first reason you have got it that if you will have ambiguous or noisy data, we may apply soft computing. Second, soft computing allows parallel computation, means it is going to implement the things very fast. Here time is not going to be required too much, whereas hard computing is strictly sequential. Soft computing can use multi-value, whereas hard computing uses only two value, means 0, 1 or 2 false. Okay, but here we may use multi-value. Soft computing incorporates stochastically, whereas hard computing is deterministic. Okay, soft computing can yield approximate answer. It gives what? Approximate answer. But hard computing is produces precise. This is the benefit. But many drawback is also of hard computing, as we have seen them. The most important goals of soft computing application in diagnosis are accurate detection, early diagnosis, and risk factor identification. Data mining is an interdisciplinary subfield of computer science. The term data mining refers to the getting or extracting or mining knowledge from huge amount of data by using computational technique. Some people understand data mining what? It is a business solution. What? It is a business solution. But it is not a business solution. It is just a technology. Data mining is the analysis step of knowledge discovery in databases, or you may also tell KDT. The most important and popular data mining techniques are classification, regression, clustering, association rule, predictive, sequential mining. Okay, so mining. Data mining techniques are used for variety of applications. Healthcare, supply chain, quant finance, marketing, social network. Okay, analysis, text mining, emotions and sentiment. These all are the applications of data mining. Here you may see data mining is used to optimize a business design. Two kinds of tasks is there: predictive and descriptive. So what is predictive task or predictive method? What is this? We should know it. Okay, what is predictive task or what is predictive method? Predictive task means to find the value of feature using the value of other feature. To find the value of feature using the value of other feature. For example, classification, regression, deviation detective, time series analysis, prediction, etc. What do you mean by descriptive task? Descriptive task means the patterns that are human interpretable. The patterns that are human interpretable. Example, clustering, association rule discovery, sequential rule, summarization. Okay, these all are the examples. So we'll move the next feature selection. Many resource person have discussed about it. So we will just see in this slide only. Feature selection is also known as attribute selection, or variable selection, or variable subset selection, or dimension detection, or feature minimization. This is commonly used in data mining. It is a process of selecting important feature, or base subset of feature, or relevant feature by removing the redundant and irrelevant, noisy, or insignificant feature, which will save the resources while improving the accuracy and ROC. So what we are going to do with the help of feature selection, we can save storage capacity, computation time, okay, computation cost, and increases what? Classification accuracy. Okay. So we have done our experiment in Vika. So what is Vika? You may tell it is a collection of machine learning algorithms for data mining tasks. The algorithms can either be applied directly to a data set or called from Java. It contains tools for data preprocessing, classification, regression, clustering, association rule, and visualization. Feature selection method or technique is the combination of such technique along with an evaluation method. The tools provide a feature selection technique which is separated into two parts: attribute evaluator, search method. In next, we will just do feature selection in Vika, as well as we are also going to perform classification. Vika uses data in ARFA format. If data is not in ARFA format, do you know what is the meaning of ARA? Attribute relation file format. Okay, you can convert it from CSV to ARA. What is attribute evaluator? The method is by which attribute subset are evaluated or estimated. Example: CFA subset evaluator, chi-squared, gain ratio, info gain ratio, classifier subset, paper subset. Then search method. What is second type is what? Search method. You have to just put up. I'll show you in Vika. Okay. Search method means searching the set of all possible features in order to find the base set of features. So the method by which the space of possible subset is searched. It may also be used for proposing new attribute subset. The method may be navigated based on evaluation based for genetic, greedy wise ranker, and exhaustive. So PMA Indian diabetes data set. I'm not going to take too much time. Only I will take 5 minutes. I'm going to wind up my session, okay? Because I will assign cues and will prepare for valedictory session. Okay. By 5:10, I have given the time in college. So before 20 minutes, I need to also assign because there is 30 objective question. You have to solve it. Okay. So PMA Indian diabetes data set, which is popular data set. Okay. Yeah, this data set you may obtain from where UCI repository. You may discuss the PMA Indian diabetes data set was obtained from UCI repository machine learning database. The National Institute of Diabetes and Digestive and Kidney originally on this data and received in 9 May 1990. All persons in this database are of PMA Indian women at least 21 years old and living near Phoenix, Arizona. This is the place. And 768 ladies were there where their age were less than 21 years old. Okay, you may see. Say instances or sample means this many number of what? Person. Person means no, means total person. Okay, and 8 number of attributes. 1 if you include class, then 9. And this is the name of attribute: number of times pregnant, plasma glucose concentration, diastolic blood pressure, type, escape fold thickness, 2 hour serum insulin. This is what, you know, unit, millimeter per mercury, millimeter, micro unit per millimeter. These all are the unit. Okay. 500 means 5 only out of 768, 268 were found diabetes and 500 was not. So this was a subject of research. Why only among 768 ladies, which all was younger than 21, and found among 768, 268 were what? Diabetes. So researcher have just researched why this is on this place. So a lot of research have gone on this data set. This is the localized data set. I have collected this data set in Ranchi. Okay, and in this data set 12 features and 3 to 8 minimum 3 were I have taken to which, okay, diabetes was suffered and 80. I have collected the data set from age 3 to 80 and total 58 instances. I took time 5 months to collect this number. In this data set, and you know, all kinds of normal, though suppose I am diabetes and to whom I have visited hospital, of course they will be normal. So I took for both, because if you collect only the diabetes patient, the data is going to be biased, and the data set means how you do research. So in this data set, both means how you are going to collect data set. It is a major role. Okay, we need to take care. And here also ethical permission was needed, committee was formed. And after that, we may do all that. Okay. So these all was a what? 12 attributes. Okay. 12 attributes. These all are the 12 attributes, and you may see here a note. I told you I'm going to take very less time, because this is name based. Okay. So I will just implement in Vika, because I don't want the last lecture you should feel good. Okay. So here example. So I am not going to focus all this. Okay. So because I am going to assign you cues last lecture, so not a burden with you. So I'm going to finish here. I will just interact with you and assign you with you. Okay. Because I may understand you all have visited, means attend how many days of what? I think you all have just the last day, and this many number of days only you listen, talk. So of course, so I will just tell you how to do classification and feature selection. Are you able to see this? If you are able to see, I may tell you. Okay, so just see here, and you have to go in train data. Just select train data. Okay, this is the train data, and what you have to do? You have to just, if you want to perform classification, go ahead. Suppose if you want to do what? Training. Okay, so decision tree you have done it. This is your what? Performance. And if you want to do what? Testing. So go here, supply data test. In front of you only I have just split data set. Okay, go ahead, go there, test. Okay, close and start. You have got this percentage. Okay, and if you want to construct what? Decision tree. Okay, how a tree has been. Okay, visualize tree. You just go visualize tree. Yeah, this tree. I think you may see this tree, and then hit to screen. Hit to screen. Okay, you may see this. In this way, your decision tree has been constructed by using this algorithm, and you have seen. So in this way, we have to use. And right now, I will come to what? Feature selection. I am just telling those who are having bio. Actually, 1-2 candidate is from bioinformatics. Few maybe from, yeah, everybody knows Python, MATLAB, each and everything. But and this is not wrong if you are using some GUI too. But the basic fundamental we should be strong enough to that. Okay. Suppose you yeah. So just select firstly data set. We have not select. So you have to just select data set. Okay. Open file. Then data set. Open. Select attribute. If suppose base such. If you want to use what ranker, or if you want to use suppose PC. In this way, if you want to use okay ranker, base first. 2, 5, 6. This is more relevant as per Vika2. So like that, and okay. So I'm going to stop sharing. I will do some interaction from you all, and okay. So I'm not going to go in too much depth because last session, and of course you'll feel bored. Only teaching and lecture, all that. Okay, but what our resource person have delivered, there were how 15 lecture plus 1 keynote talk. Okay, so I'm going to assign you what cues. There will be 30 questions from each session. 2 questions will be there. Okay, and you have to just do within 20 minutes. So right now your time is what? 4:45. and you have to do it by 5:05, and valedictory session will be started by 5:10. Okay, is there any kind of doubt? That's why I have not taken my lecture. Yeah, that's why I have stopped my lecture. You should not feel bored, or you should, yeah, you should do the things in a relaxed way. Okay, so I'm going to share. Just one second. So I'm going to message you in your WhatsApp group, as well as in this screen. I'm also going to share. Okay, this link. So please submit this, but you all have to attend to get certificate, and you all have to attend what? This uh, valedictory. Okay, so I'm also giving you in, and you have to finish by 5:05. So okay, just do complete. If you want to tell me something, hoping that we have done our part from our end, every and oh, of course, within 5, I may understand within 5 days what you may learn, but of course you will be benefited, because I have also received some call. Sir, it was nice short-term course. I have learned a lot. You have given good idea. I was just telling to each and everyone, attend it. You are going to be benefited. Only within this 500, what you are going to get it. And okay, so thank you. But you, without your support, it was not possible. And but just complete. Okay, so complete within 20 minutes. So what is the status? Have you completed queues? Please do it within 5 minutes. Hoping that you are going to complete this within 2-3 minutes. So you are having time just by 5 because Valedictory is going to be started sharp 5:10.
स्टार्ट करें।
Honorable Director Sir, Professor Arvind Choube, Registrar in Charge Dr. Gaurav Kumar, HODs of several departments of IIIT Bhagalpur, my dear faculty colleagues and staff, dear participants and students. Now we have come to an end of our 5-day short-term course on AI and data science in healthcare. So at the very outset of this valedictory session, I would like to request Dr. Dilip Kumar Choube to felicitate our Honorable Director Sir with a shawl and bouquet.
I would like to call our HOD, Dr. P.K. Bishwal. Dr. Babul Prasad Tiwari will welcome him by bouquet.
Now I would like to call the coordinator, Dr. Dilip Kumar Choube, for his concluding notes about the workshop and feedback taken.
Good evening, everyone. Respected Director Sir, Registrar in Charge, HOD, CSC, and other department head, faculty members, staffs, media persons. Firstly, I would like to wish you all a very warm good evening. The goal of this STC was to provide an industry level knowledge in the field of AI and data science, with specifically in its application in healthcare. Now summarizing this 5-day STC on AI and data science. On the first day, we started with our inaugural session, followed by Honorable Director Professor Arvind Choube welcome speech. Then the chief guest of this STC program, Sarath Kumar Patra, gave his inaugural speech and enlightened us all with a brief introduction of AI and data science. Our guest of honor, Mr. Kundan Lal, made us aware about the role of AI and data science in industry. Then came the keynote talk of this STC by Professor Ravi Bhushan Mishra, who gave a very informative insights on recent trends of AI and machine learning methods in medical computing. Our first talk, Dr. Dilip Singh Sisodia, NIT Raipur, told us about decision tree-based machine learning model, how traditional programming and machine learning works, and about designing of ML-based spam filter, and also made us familiar with different ML models like supervised and unsupervised, and also about decision tree algorithm and its implementation in Python. Thereafter, Dr. Prabhat Kumar, NIT Patna, talked on IoT in healthcare. He informed us about history and evolution of IoT and its impact in today's growing world. The video he showed was quite visionary. He also informed us about application of IoT and various smart technology. Then Professor Rajiv Misra, IIT Patna, gave his lecture on deep learning for rapid drug discovery. He gave insights on how deep learning models along with biological technology are used in rapid drug discovery. He also talked about computer-aided drug design and how molecular representation can be converted to a graph. On the second day, Dr. Behoshoni Manit Bhopal gave an expert talk on deep learning based human activity recognition in healthcare. He provided us with invaluable insights about deep learning based human activity recognition, which has wide application like sports injury detection, elderly care, etc. Dr. Rahul Amar IIM Kanchipuram with his expert lecture on bioinformatics and healthcare through intelligent image analysis for humans, informed us about artificial intelligence, its purpose, application, risk involved in it. He also talked about its types, image processing and computer vision. Then you informed us about GATE and bioinformatics in humans and animals, how computer vision helps in healthcare and how humans are identified using it. Dr. Jiten Kumar VIT Vellore gave a expert talk on modeling and simulation or regression analysis and predictive modeling. He is he informed us about decision modeling and simulation. He also informed us how we can say that a formula or an equation is model or not. Its types, deterministic and probabilistic, and steps involved, data formulation, solution, implication. On the third date, Dr. Maheshwari Prasad Singh, NIT Patna, gave his expert talk on multi-scale feature for malignancy detection in lung cancer. He made us aware of multi-scale CNN-based feature extraction for malignancy classification and detection of pulmonary lung modules for lung cancer. He also talked about lung cancer, CT scan, need for CAT systems. Dr. Prakash Kumar Singh from IBM with his lecture on application of deep neural networks in healthcare gave insights on application of deep neural network in healthcare. He also talked about Indian healthcare system and government programs to improve it by digitalizing the system and also about challenges related to it and how they can be overcome by using cloud computing technology like AWS, GCP, Azure. Dr. Sandeep Raj, IIIT Bhagalpur, gave his expert lecture on biomedical image analysis using machine learning and deep learning technique. He talked about development of hardware prototype of an efficient method for handheld arrhythmia monitoring device. Then he talked about cardiovascular disease, ECG, arrhythmias, and also informed that the detection and treatment is very costly and how you have developed a cost-efficient way for that. On the fourth day, Dr. Ranjan Kumar Behra, IIT Patna, gave his expert lecture on IoT and its application. He provided us with invaluable insights about Internet of Things, its history, different devices used. He explained how the IoT technology works using the Internet gateway device and sensor and informed about different gateway devices like Raspberry Pi, architecture of IoT system, TCP/IP protocol. He also told us about the driving forces of IoT, data, sensors, cloud, etc. Dr. Chandrasekhar Azad, NIT Jamshedpur, with his expert lecture on supervised learning using Python for healthcare, informed us about ML, how it is different from traditional programming, different ML techniques, its life cycle, types, how it works, various ML tools, its application in real world like recommendation system, especially in healthcare sector. He also informed us about how ML techniques can be used in diabetes diagnosis and prediction. Professor Kalyan Chatterjee, IIT Dhanbad, gave his expert talk on detection of fatal diseases from biomedical signals and image using hybrid deep neural network model. His insights involve detection of fatal disease from biomedical signals using hybrid deep neural network. He talked about CBT and tumors, also about novel feature selection technique, ECG, arrhythmias, myocardial infarction, MIT BIS disease. He explained the methodology by denoising using MRDWT, baseline, wonder removal, R-peak detection of ECG, feature extraction algorithm, confusion matrix, and use of MLPNN. On the last day, today, Dr. Sudhakar Tripathi, RC Ambedkar Nagar, gave his expert talk on classification in health informatics for disease prediction using ML technique. Talked about AI, ML, data science in healthcare for disease diagnosis and prediction, and also talked about the prediction that should be done using ML like disease drug discovery, diagnostic service, multimodal analysis. Dr. Astos Mishra, TIIT Patiala, with his expert lecture on ML models in software development, informed us about MLDL techniques for prediction of neurodegenerative disorder. He also informed us about symptoms and treatment of Parkinson disease. He then talked about why and how we use different ML algorithms like SVM, random forest, decision tree, and ANN, CNN models for brain image classification, and various ensemble and autocorrelation method to predict the Parkinson disease. Today, last on I have just discussed classification for motivation. what is the motivation for classification in healthcare system. I discuss about motivation of AI and data science in healthcare system. Also about how to partition data set by using Vika. If you are facing issue manually with, then you may do it by using Vika with hands-on overview. I also discuss and give overview how to implement feature selection classification in Vika. After all expert lecture, I am certain that the goal has been reached and the participants now have a very good idea about AI and data science. I thank all the speakers and the participants for making this STC a successful event. I would like to express my gratitude towards Director Sir, Professor Arvind Chaubey. Director Sir has always been a source of motivation. He never fails to amaze us with his ability to inspire us to challenge ourselves, enabling us to leap forward. Sir, your charismatic energy and devotion to our institute is an inspiration. Thank you, sir, for providing me with such a wonderful opportunity to coordinate this short-term course. So right now I will come to feedback session. Involvement of participants is the key to success of any event. Thank you, participants, for such an overwhelming involvement in this event. I hope this short-term course was worth your time and has provided you all with great insights and knowledge in the field of AI and data science. I look forward to your feedback, be it appreciate or of criticism. So please feel free to express your mind. I am an optimistic kind of person. Our director sir is also an optimistic kind of person. If positive, then it is a compliment. If negative, in the future we will try to incorporate it. So please, one by one.
Good evening, everyone. I'm Satyam from MTech CSC Department, IIT Bhagalpur. I would like to give my feedback. I found this STC very helpful for my AI ML studies, and I'm sure that this STC will help to grow in the field of AI. And I thank Director Sir, Dilip Sir, and the whole CSC Department of IIT Bhagalpur for organizing this amazing short-term course. Thank you.
Next.
Hello. Hello.
Yes, audible.
Yes. Good evening, everyone. Myself, Dr. Mukesh from Noida. And I would like to say that the entire session was extremely good. It was very informative. And I hope the such events is going to organize by you in the future also. Hello.
Yes, sir. Audible.
Yes. Am I audible?
Yes, audible.
Sir, I want to say that the session was extremely good. It was very informative. And we are expecting many more in the coming days from IIT Bhagalpur. That's all from my end. Thank you.
Okay, sir. Next member, please. Next participant.
Hello. I am from Gaya Engineering College, and the course taught us the inside the deep learning AI IoT. We all know many the things in AIT ML. We get the valuable information through this online courses. We want the such informative courses offline. I deeply thanks to IIT Bhagalpur Director Sir, Dilip Sir. So thank you, sir.
Okay, next participant.
Good evening, sir. Myself Vishal Soni. I'm from IIT Bhagalpur, first year student. Sir, thank you, sir, for making this short-term course available on artificial intelligence and data science in healthcare system. There's so much to learn, and there's so much to learn about various fields. And thank you so much, sir, for making this course available. Thank you, sir.
Okay, next participant.
Good evening, sir.
Good evening.
Yes. Anyone, please. Divya.
Good evening, sir.
A very fine good evening to respected Director Sir, Registrar Sir, HOD of respective departments, faculty members, and all the respected dignitaries present there. I am grateful to IIT Bhagalpur and Dr. Dilip Kumar Chaubey Sir for organizing such an enlightening short-term course on artificial intelligence and data science. The course has given me a lot of clarity about the application of AI and DS, and I can further use this knowledge for my project purpose. It has been very informative session, and I am looking forward to attend some more short-term course organized by Triple IT Bhagalpur. Thank you, sir.
Okay, Divya. Next, Dhruv, you are telling, you are giving some feedback. Welcome, please.
Good evening, sir. Myself Dhruv Srivastava. I am from Triple IT Bhagalpur, first year student. I would like to thank Dilip Kumar Chaubey sir for such an insightful session that gave us information about various topics in the field of artificial intelligence and machine learning. Looking forward to many more such sessions. Thank you, sir.
Yes, next participant.
Good evening, everyone. I am Sanskriti Shreya. I have completed BTech in Electronics and Communication Engineering, and I am currently training in VLSI design from Maven Silicon. This course has been has been very informative, and I have learned a lot about AI, and I believe that it will help me in VLSI design also. I would like to thanks Triple IT Bhagalpur for organizing this short-term course. Thank you.
Okay.
Good evening, sir. So this is
Yes.
Priya Dubey, a research scholar from BIT Meshra, Ranchi. And thank you, sir, for organizing this valuable short-term course. And my research topic is I'm actually working on prostate cancer model and looking forward to go for AI and ML for the cancer detection. And this course has provided me nice theoretical theoretical knowledge about how I can use this AI and ML in biomedical research. And I will be looking forward for more such courses from your side. So thank you so much.
Okay, thank you, Priya. Next participant.
Good evening, sir, and good evening, all of you. My name is Sumedha Sharma. I am a research scholar from University Noida. It is a very useful short-term course for me, and I am really thankful to sir. Such a useful information I get. My suggestion is, sir, more practical session. If you can include in this short-term course, it will be very useful for me. I'm for statistical background. That's why I need one practical session.
Thank you. Of course, in the future, we are going to do it. We are going to implement this, and
Okay, thank you so much,
practical
sir.
session will be more and more. Thank you for the suggestions. Next participant.
Good evening, sir. Myself Rakesh Prasad, and I am from Central University of Rajasthan. Still now I am in train, but I am attending this course. Attend this course, and this course gives us great knowledge from various faculties, from various institutes. So thank you, especially sir, you for conducting this course. Thank you, sir.
Good evening,
Okay,
sir.
thank you. Yeah, next member. Yes.
Good evening, sir. I am
Yes.
Krishnakant
Good
Kumar.
evening.
I am Krishnakant Kumar from Triple IT Bhagalpur, fourth year CSE student. Sir, I am glad to provide such type of wonderful session. My overall experience has been very amazing, and you have provided such a good opportunity to grow and explore my skill through this short-term session. So, thank Dr. Dilip Kumar Chaubey, sir, director, sir, and all Triple IT Bhagalpur team.
Okay, thank you, Krishnakant. Next participant, please. Some suggestions.
Good evening, everyone. I'm Rajiv Ranjan, first year CSC student from Triple IT Bhagalpur itself. I got to learn a lot about machine learning, its types, applications of IoT in healthcare, and many more. I would like to thank Dilip sir, Honorable Director sir, and all the spokesperson involved in this short-term course. And I would love to explore this in coming future. Thank you so much.
Thank you. Next participant. Next. So I would also like to call Rishabh. You are physically here present. You just come here and give your feedback.
Thank you, sir, for conducting this such an informative short-term course. Sir, I've learned a great deal from it, and it was very informative. We learned various things from IoT to decision trees, how to predict diabetes prediction to cardiac prediction. There were a lot of things that I have learned. Thank you, sir, so much for conducting this short-term course. Thank you.
So thank you. If some suggestions, then please. Actually, 10 to 15 are from VIT Vellore have registered, but no one has given from VIT Vellore. 10 to 15 persons are from VIT Vellore.
Yes,
Among,
sir.
yeah.
I am Sonia. I am doing PhD from Valedictory Institute of Technology, Tamil Nadu. This short-term course work is useful for me because I am doing PhD in biostatistics. It helped me how to apply machine learning and predictive model in healthcare. Actually, I am very thankful to Jitendra sir, Dr. Jitendra sir, who suggested me attend this short-term course. This is very informative session for me. Thank you so much, sir.
Okay. Next member, next participant, please.
Good evening, sir. This is Rubia from Velamal College of Engineering and Technology, Tamil Nadu. This is really an eye-opening session for the new research people, and I thank all the faculty members who gave an excellent knowledge about the IoT and machine learning, AI, and so on. So thank you everyone for giving this wonderful opportunity to learn this from you. And I want to thank IIT Bhagalpur for arranging this wonderful session. Thank you so much.
Okay, thank you. Next.
Good evening, everyone. My name is Arnab De. I'm from Bihar Institute of Technology. And this session in particular was very much essential for us students who were looking for going into the data science as well as for machine learning related fields. And to be very honest, it really helped me understand about the various topics related to the subjects and how we can implement it in our further projects and our future projects. And thank you so much, sir, and all our respective faculties. And thanks to Jitendra Kumar sir, who recommended me to attend this session. Thank you.
Okay, okay. Thank you, Arnav. Next member.
Hello,
Yeah.
hello, good evening,
Yes.
everyone. I'm Shalja, and I am currently doing BTech degree from CSC department in Triple IT Bhagalpur. And I would like to thank everyone, especially our sir, Dr. Dilip Kumar Chaube, and for providing such a wonderful short-term course. And we come to know many research projects in this course. And yeah, I would like to do something in this area, AI and machine learning in healthcare. Thank you, everyone.
Okay, thank you. Please, next participant, give some feedback.
Yeah, good evening, sir. I am Anjali, and I am doing my research under from VIT Vellore. And Dr. Jitendra sir suggested me to attend this short-term course. So I found that especially two lectures, I found very useful for me. What I'm doing that is very suitable for me. Like first one is like deep learning based human activity recognition in healthcare. I'm not working in the field of healthcare, but this human activity recognition, I found this lecture very useful. And one more was there, that is application of deep neural network. So overall, this short-term course was very helpful and very informative. Thank you, sir.
Okay, thank you, Anjali. Next member, next participant, please. We need also some suggestion what we are going to incorporate in the future. Okay, welcome. If you have if from your side some we are lacking somewhere, you may directly tell us.
Good evening, sir.
Yes, yes. Good evening, please.
Sir, I'm Vishal Soni. I would like to give a suggestion. Sir, from next time, kindly make a special session in which student can give their research ideas, so that more and more ideas can come and we can applicate next time.
Okay, Vishal. Definitely, we are going to incorporative. Okay.
Thank you.
Next participant.
So I also have a suggestion. Priya Dubey this side.
Yeah.
Yes, actually, I want to suggest that if there can be a short-term course like this on how to use like data, how to gather the data for AIML, like there are lots of databases existing, like Kegel for image processing, and some cancer data access systems are also there. So how to get those data? Because being a research scholar, I found it very difficult to get the data. So if there can be some courses or suggestions and how to utilize that data for machine learning algorithms.
Okay. Okay. Thank you. Of course.
Thank you,
In
sir.
the future, we will take care of it.
Thank you, sir.
Next participant. So I think we have given too much time, but one or two feedback we may take it because there are so many participants. So of course that's why we should spend time on your feedback. So please, last one or two. No. So we should
Sir, good
close.
morning. Sir, good evening, sir. Sir, I am Tushar Bharti from CSC branch, Triple IT Bhagalpur. Sir, I wanted to give a suggestion that in some courses we have a code as a base for examples. Like in yesterday class, the last class, sir gave a Python code as an example for how we do AI or ML. Also, I want to suggest that we should have more such kind of lectures where the lecturer explains the main idea in theory and also give an example algorithm or code format so we can understand what is going inside the code too. So because in theory we can understand, but when applying, I also and many others also found it difficult to how to apply those theorem correctly. So because there are chance that more complex algorithms comes with more complex codes, and because we are currently new and learning, we can make more mistakes on this.
Definitely. We are planning to conduct short-term course even in just offline mode. So, of course, when our college is going to be open, you will see such kind of courses we are planning to conduct. Okay. Thank you for your suggestions. And next participant. Okay, so thank you for feedback session. And of course, what suggestion we have given to us, we are going to implement in the future. Thank you everyone. Thank you each and every participant. Only by you, this event has got success. Thank you from my side to all of you. Okay. And actually, we our planning is also to take one pic. So please, I'm requesting from each and everyone, you put on your camera, by which we may click some pics. Okay, participants, it is my request from you all. Please put on your video camera if is it possible from your side, because we want some pics. Okay, so please do it. Everyone, it is my request from each and every participant. Please do it. वीडियो हिंदी में मैं बोलना चाह रहा हूँ, सब लोग वीडियो ऑन कर लें। आप लोग सभी पार्टिसिपेंट से रिक्वेस्ट है ताकि हम लोग फोटो सेशन भी कर सकें। सभी लोग कर लीजिए। कुछ लोग साउथ से हैं इसलिए हम हिंदी बोलना पसंद नहीं कर रहे थे। ठीक है, सभी लोग कर लीजिए आप। थैंक यू।
All the participants are requested to put their camera on so that we can have a photo session. All of you are requested to put your camera on so that we can have a photo session. Now I would like to request our coordinator, Dr. D.K. Choube, to felicitate our Honorable Director, sir, with a memento. I would also like to request our coordinator, Dr. Dilip Kumar Choube, to felicitate our register in charge with a memento. I would like to request our Honorable Director, sir, to present our coordinator, Dr. D.K. Choube, with a memento. Now see, the supporting members always play an excellent role for the success of any short-term course or any event. Therefore, I would like to request our Honorable Director, sir, to inspire the supporting members with some gift. I am going to call the name one by one. So first, Dr. Pradeep Kumar Biswal, HOD CSE. Dr. Rupam Bhattacharya, Assistant Professor, CSE. Dr. Tejaswini M, Assistant Professor, CSE.
Now Dr. Babul Prasad Tiwari, Department of CSE. Ashok Kumar, Ashok ji, Department of CSE. Love Pandey, Department of CSE.
Rohit ji. Mr. Adarsh Bera. Mr. Saurabh. दिलीप सर, सभी तो बुलाया क्या? मंजित का है नहीं।
इमरान को बुला दिए। रोहित इमरान दोनों को।
मिस्टर इमरान।
और उसके बाद एमटेक स्टूडेंट और बुलाता है। एमटेक स्टूडेंट का नाम।
मिस्टर रोहित। Rishabh, MTech student. और Abhilasha Bharti. Now I would like to request our Honorable Director Sir to say a few words.
Good evening to all. My special gratitude to Professor S.K. Patra, Chief Guest of the Innovation Function, Director Triple IT Madhura, vote of the uh, the second guest was that is the Kundan Lal, who is the president of the VT Research Foundation. Keynote speaker, Professor R.B. Mishra. So all these three dignitaries was in the present one was present in the investor session. So my thanks to all these professors for join this AI course, given their time, valuable time for this AI course. On this occasion, this 5 days AI in the area of healthcare, it is a very informative, and it is the in the present scenario which is going on, or honorable PM already said 4 5 years back that AI, data science, cyber security, that is the IoT, these are the burning area, and people should think about the research work in this area. So one of them was the AI and the healthcare. There's so many areas AI is the people using this AI techniques tools for the easiness of that work. So in the health area, it is the lot of work. Triple IT Bhagalpur is also doing the work in this area, and you are familiar that ICMR has approved the this Corona software, the COVID-19 detection software by the X-ray. In the just I informed to me in the 15th May to 20th May, in between, Honorable Cabinet Minister Health, Government of India, Sri Mansukh Mandiaji will going to inaugurate our software with the other companies in Gujarat. So anytime I will receive the information, but it is informed to me that it should prepare in between the 15th and the 20th May. Just 1 hour before, I was in nearby the universities, that is the BAU, Bihar Agriculture Universities, and since 1 year, some projects works is going on, and just it was discussion. The project cost is around 1.5 crore, and the task is in the farming, in the farmers, those who are plants diseases, suppose in the paddy and the wheat, they will take the photographs of that disease and send to the their the Bhagalpur, Bihar Agriculture University, and on the basis of the AI, the scientists of the there will inform to the that farmers in your field you use this pesticides. So this is now it is doing manual, but Triple IT Bhagalpur is going to prepare the software, that is the automation, as soon as farmers send to their images of the plants, those who are affected by the insects, uh, immediately when comes in the server, and their reply will they will receive the reply. You use these pesticides in particular, that is the plants, means paddy, maybe wheats, whatever in the animals. So just in the 2-3 days we'll do the MU also from the dietary. So this is the agriculture area. So a lot of area is going on, not only fixed the agriculture, in the area of the health, in the that is the e-commerce, everywhere. If you think so, whatever the you got the knowledge in the 5 days, just this is the not the full and final. It is it is the starting of journey. You do the how AI, ML, and data science is using in a particular case, in the particular projects, and it's depends on you. Fix the one case studies, and then implement this AI, ML, and data science. Generally, in the AI, that is the training and the testing. So whatever the data you use for the training for the AI, so 50%, suppose 10,000, so 5,000 data used for the your testing, your training, and the 50% data used for the your testings, because data is just some uh, participants saying that where you find the data. So there's so many sites, that is the GitHub and the uh, uh, other sites. You can get the data free, but that data is not reliable, because in the during the ICMR, when you data collected from the GitHub, then a high level committee in the chairmanship of the Dr. Guleria, EMS director, told me that, Professor Chaube, can your data is effective in the Indian environment, because that X-ray was not from belongs to the India. That X-ray was from the outside of the India, so Canada, something other side. So I told to the Professor Gularia, is any site is available to get the data of the X-rays? So he denied, and finally he told me that you do the something MU with the any hospitals, then you get the data. So finally we do the MU with the EMS partner, and we get the data from the that place, and then that software, that the corona detection software will be fruitful. So no doubt, data is the very, in this case, in the BAU, that is the Bihar Agricultural University. Again, question is how to get the data of that images which is affected from the affecting in the farming. So no doubt, data will provide by the farmer. The farmer will snap the that affected part of their plants and send to the that is the server. So whatever the data is coming, suppose 5,000, 10,000, then we train our AI to detect the that part. It is the affecting of the which disease. So each and every disease, each and every plant, that is the 5,000 to 6,000 data is necessary for the training and testing of the that thing. So my suggestions, you collect the data. No doubt, collection of the data is the very difficult, and data, how to suppose Excel data is and how satisfied that this data is validate that data is for particular disease, because all data should be authenticate by the something doctors. This belongs to the tuberculosis, this belongs to the that is the heart disease, something that is the asthma, like this way. So each and every X-rays that is validation by the experts. So you should need some expert also to verify that data. Whatever data available in the free, it is not sure that all data in the same similar natures. So you should care. You should care, because you are facing these problems. So no doubt, this is just starting, and Actually, this is the online mode that the expert and the applicants both means your participants both are in the online mode. So no doubt it is better than if this type of the workshops will be offline. If you come here, we happy and all the softwares and the that is a high end or desktops we have. So it will be work that is the hands-on practice we do here. So it is the fruitful, it is more fruitful because by the theory and the practical it is a lot of difference. So I thanks to the coordinators 5 days and the large participants, that is the more than 75 participants are here to participate this workshop. All the faculty members of the computer science engineering, is electronics communication engineering, mechatronics, those who are help to these workshops, staffs, and the technicians, each and everyone, I will give the thanks to conduct this workshop naturally. Thank you.
Now I would like to request our HOD CSE, Dr. P.K. Biswal, for the vote of the thanks.
A very good evening to everyone, Honorable Director Sir, faculty members, staffs, and a very good evening to all of you. Now we are approaching to the end of this valedictory section. Now I would like to express my sincere gratitude to our Honorable Director Sir for his kind guidance and support to organize this short-term course. I would like to thank Chief Guest Professor S.K. Patra, Director IIIT Barodara, Guest of Honor Mr. Kundalal, President of BT Foundation, and keynote speaker Professor R.B. Mishra Sir, NIT Patna, for accepting our invitation and their valuable talks in the inauguration session. I thank all the experts, starting from Professor Kalyan Chatterjee, IIT ISM Nanmar, Dr. Ranjan Kumar Behra, IIT Patna, Dr. Maheshwari Prasad Singh, NIT Patna, Dr. Prabhat Kumar, NIT Patna, Dr. Dilip Singh Sosodia, NIT Raipur, Dr. Sudhakar Tripathi, REC Ambedkar, Dr. Prakash Kumar Singh, Data Science, IBM India, Dr. Vaibhav Soni, MNIT Bhopal, Dr. Chandrasekhar Azad, NIT Jamshedpur, Dr. Rahul Ranjan, IIT DM Kanchipuram, Dr. Jitendra Kumar, VIT Vellore, Dr. Ashutosh Mishra, TIET Patiala, Dr. Sandeep Raj, IIT Bhagalpur. Really, your lecture sessions are very interesting and enthusiastic. I would like to express my heartiest thanks to all the participants for their active participation in this short-term course. I am confident that you must have got a lot of knowledge in artificial intelligence and data science and their applications in various sectors of the healthcare. I would like to thank the MTech student Rishabh for his support for the conducting this short-term course. Finally, I would like to thank the coordinator, Dr. Dilip Kumar Chobe, for conducting this well-organized short-term course. He put a lot of effort for smooth conducting of this short-term course. Once again, I thank to Director Sir for his kind guidance and to organize such type of events. I would like to thank all the HODs, registered faculty and staff members for their kind help and support to make this short-term course a grand success. Thank you all.
So that's all from this valedictory session. Thank you very much. Participants will get their certificate very soon. Thank you very much. recording session will be provided in the link. Thank you. If you have any other question, you may ask. Dear participants, if you have any other question, you may ask. Thank you. Thank you very much.